Good morning, everyone. It is with great pleasure that I, on behalf of the organizers, welcome you all to today's interactive meet on career in mechanical engineering. I now invite Mrs. S. HEMAA, Senior Scientific Officer, Science City, Chennai, to inaugurate the session. Yes, ma'am, please.
அனைவருக்கும் என் இனிதான காலை வணக்கம். எனது பெயர் எஸ். ஹேமா. தமிழ்நாடு அரசின் உயர்கல்வித்துறையின் கீழ் இயங்கும் அறிவியல் நகரத்தில் முதுகலை அறிவியல் அலுவலராக பணியாற்றி வருகின்றேன். அறிவியல் நகரம் திரு யு. சகாயம் இந்திய ஆட்சிப்பணி அவர்களை துணைத் தலைவராக கொண்டு செயல்பட்டு வருகிறது. அறிவியல் நகரம் மற்றும் இந்திய தேசிய இளம் அறிவியல் அகாடமி புதுடெல்லி இணைந்து நடத்தும் இயந்திர பொறியியல் துறையில் வழிகாட்டல் கரியர் இன் மெக்கானிக்கல் இன்ஜினியரிங் நிகழ்ச்சிக்கு வெபினார் மூலம் இணைந்து இருக்கும் அனைத்து மாணாக்கர்களையும் வரவேற்பதில் பெருமகிழ்ச்சி அடைகிறேன். இந்நிகழ்ச்சியானது 12ஆம் வகுப்பு மாணாக்கர்கள் தொழில்நுட்பத் துறையில் இயந்திர பொறியியல் துறையினை நாம் எடுத்தால் எதை பற்றி எல்லாம் படிப்போம். இத்துறையில் படித்துக் கொண்டிருக்கும் மாணாக்கர்கள் மேற்படிப்பு மற்றும் ஆராய்ச்சி படிப்பினை மேற்கொள்வது எப்படி, மேலும் இத்துறையில் வேலை வாய்ப்புகள் எவ்வாறு இருக்கும், இத்துறையில் படிப்பினை முடித்து சுய தொழிலினை மேற்கொள்ள விரும்பும் மாணாக்கர்களுக்கு வழிகாட்டியாகவும் இந்நிகழ்ச்சியானது நிச்சயமாக அமையும். இந்நிகழ்ச்சியில் பங்கெடுத்துக் கொண்டிருக்கும் மாணாக்கர்களை துறை ரீதியாக வழிநடத்தி கொண்டு செல்வதற்கு பல்வேறு தலைப்புகளில் உரையாற்றிட வெபினார் மூலம் இணைந்திருக்கும் அண்ணா பல்கலைக்கழகத்தின் இயந்திரவியல் துறையினை சார்ந்த பேராசிரியர்கள் முனைவர் கே. சண்முக சுந்தரம், முனைவர் எஸ். பாலசிவானந்த பிரபு, முனைவர் டி. கணேஷ், முனைவர் சாமுவேல் ராஜ் ஆகிய சான்றோர்களையும் கேட்டர்பில்லர் இந்தியா பிரைவேட் லிமிடெட் தொழில் நிறுவனத்தினை சார்ந்த தொழில்நுட்ப வல்லுநர்கள் முனைவர் ஜி. பாலகிருஷ்ணன் மற்றும் திரு சங்கர் சுப்புரத்தினம் ஆகிய அனைவரையும் அறிவியல் நகரம் மற்றும் இந்திய தேசிய இளம் அறிவியல் அகாடமி சார்பாக வரவேற்பதில் பெருமகிழ்ச்சி கொள்கிறோம். இந்நிகழ்ச்சிக்கு நிறைவு உரையாற்ற இணைந்துள்ள முனைவர் என். ராதாகிருஷ்ணன், உதவி பேராசிரியர், தாவரவியல் உயராய்வு மையம், சென்னை பல்கலைக்கழகம் அவர்களையும் இந்நிகழ்ச்சியினை நடத்தி கொண்டிருக்கும் இரு நிறுவனங்களின் சார்பாக வரவேற்பதில் பெருமகிழ்ச்சி கொள்கிறோம். மாணாக்கர்களுக்கு தொழில்நுட்ப கல்வியில் உயர்கல்வி வழிகாட்டிட இந்நிகழ்ச்சியினை வெபினார் மூலம் வழிநடத்தி கொண்டிருக்கும் முனைவர் எம். முத்தமிழரசன் அவர்கள் தெலுங்கானா மாநிலத்தில் உள்ள ஐதராபாத் பல்கலைக்கழகத்தில் உதவி பேராசிரியராக உயிர் அறிவியல் துறையில் பணியாற்றி வருகிறார். மேலும் இந்திய தேசிய இளம் அறிவியலாளர் அகாடமியின் உறுப்பினராகவும் நன்முறையில் செயல்பட்டு வருகிறார். இந்திய அரசின் இன்ஸ்பயர் விருதினை பெற்றவர். தனது ஆராய்ச்சி பணிக்காக விருதுகளை பெற்று இதன் மூலம் இளம் வயதிலேயே தனது ஆராய்ச்சி படிப்புக்காக வெளிநாடுகளில் தொடர்ந்து ஆராய்ச்சியினை மேற்கொண்டு முனைவர் பட்டம் பெற்ற இளம் விஞ்ஞானி ஆவார். அறிவியல் நகரத்தின் சார்பாக முனைவர் எம். முத்தமிழரசனை வரவேற்பதில் பெருமகிழ்ச்சி கொள்கிறேன். இந்நிகழ்ச்சிக்கு சுமார் 430 மாணாக்கர்கள் பதிவு செய்துள்ளனர். இதில் 400 மாணாக்கர்கள் தமிழ்நாட்டினை சார்ந்தவர்கள் ஆவர். கொரோனா தொற்றின் காரணமாக பள்ளி மற்றும் கல்லூரிகள் இயங்கிடாத நிலையிலும் மாணாக்கர்கள் தங்களது முன்னேற்றத்திற்காக தங்களது கல்வி பாதையினை தயார் செய்து கொள்வதில் முனைப்பாக உள்ளனர் என்பது இதன் மூலம் நன்கு அறிந்து கொள்ள முடிகிறது. வெபினார் மூலம் இணைந்து இருக்கும் அனைத்து மாணாக்கர்களையும் மீண்டும் முறை வரவேற்பதில் பெருமகிழ்ச்சி அடைகின்றோம். தற்பொழுது முனைவர் முத்தமிழ் அரசன் அவர்கள் இந்திய தேசிய இளம் அறிவியலாளர் அகாடமியை பற்றி கூறிவிட்டு மேற்கொண்டு இந்நிகழ்ச்சியினை வழிநடத்தி கொண்டு செல்ல அன்புடன் அழைக்கின்றேன். நன்றி.
Thank you, ma'am, for your brief introduction and welcome note. I don't have any slides for Indian National Young Academy of Sciences, but still I could say that it is very much pleased to work with Science City Department of Higher Education, Tamil Nadu, through you, of course, in communicating science as well as career opportunities, as well as even for school students, even on policy front. We were doing several activities, and this is one such program where we are targeting the mechanical engineering students to show them the path ahead in their career. So with this, let's begin the session with our first speaker, Professor K. Shanmuga Sundaram, who is a professor in mechanical engineering. at Engineering Design Division, CEG, Anna University, Chennai. He has completed his UG and PG from GCT Coimbatore and PhD in Mechanical Engineering from Anna University. He has broad area of specialization in engineering design and special interest in new product design, hydraulics and pneumatics, machine design, composites, electromagnetic forming, additive manufacturing, to name a few. He has written a book on hydraulics and pneumatics and published by S. Chand and Co. in 2006. He has also been in administration of Anna University as PS to two vice chancellors between 2006 and 2012, and he is appointed as head engineering division since 2013 till 2019. Presently, he is the additional director of AU FRG Institute for CAD CAM. So far, he has completed supervising 5 PhD scholars, and 3 scholars have already submitted their theses. And currently, 11 scholars are doing research in his area of special interest. He has completed 1 CARS project and completed 7 consultancy projects in the area of new product design and fabrication. And in this area, he has published more than 85 papers in reputed international and national journals and conferences. He has also filed 1 patent, and it is in its final stage of evaluation. Altogether, Professor SHANMUGA has 20 years of teaching, research, and administrative experience, which makes him the right person to start today's session on career in mechanical engineering. Sir, please.
Thank you very much, Dr. Muthamalasan and Mrs. HEMAA from Tamil Nadu Science City. I take great pleasure in thanking the chairman of Tamil Nadu Science City, Mr. Sahayam, Mrs. HEMAA, the scientific officer, and Professor Muthamalasan from the University of Hyderabad on behalf of the Indian National Youth Academy of Sciences. And I also, in absentia, place on record our sincere thanks on behalf of all my colleagues to our Vice Chancellor, Registrar, and our head of the department for permitting us to have this interactive session with the students in spite of this corona pandemic, where people have very great difficulties in having day-to-day interaction with the teachers. And among the 440 participants who have enrolled for this course, I'm quite happy that most of them are once again from the engineering discipline, probably not mechanical, from all the other disciplines. And it would be a great insight for those people who are already engineers. And also, it is going to be a comprehensive lecture webinar for all the students who are also from the +2 stream, who are just waiting to get into your options of entering into an engineering college. So, what is mechanical engineering? I'm not here to market any engineering. So, we are here to give you a great insight, probably both from the academics, also from my friends from Caterpillar, Dr. Balakrishnan, and his colleague, to give what are the ways in which mechanical engineering is becoming more versatile. And we can very confidently say this mechanical engineering is the most diverse and versatile engineering discipline. And if at all you think any part that you start your day, starting from the brush till whatever you think of at the final stage, there is going to be at least a part of the solution or a complete solution that a mechanical engineer is going to provide. And as you all know, since the Industrial Revolution way back in 16th century, the physics and mathematics have played a major role, and the application of science is your engineering. But once the material science was also having its equal importance, people started this science to convert it into an application. That is how the engineering came into action. And once it was the preliminary, the old terminology called as oil, coil, soil. Oil stands for mechanical, coil stands for electrical, and soil stands for your civil engineering. This was the only courses that were thought about. But towards the beginning of the 21st century, as well as the later part of your 20th century, you could find many other disciplines because of the continuous growth of your computers and electronics, and it was standing at the peripheral of all the systems of your electrical or mechanical. And since you could feel those kind of things are going to not affect much, people were not too much interested. So your mechanical engineering was remaining as it is. But as of today, does it have any specific relevance? Does it have a scope? And how important is it for this 21st century is what I'm going to make you aware of it and probably inspire to feel proud to be a mechanical engineer, as most of you are from the Department of Mechanical Engineering. And for those people who are waiting to enter into your engineering discipline, I would rather say if you have specific interest or an inclination to design a product, go ahead with this development of the existing products, because we are talking about design for enhancements today. It is not that we are going to just stop with older products, come out with new products itself. So if you are going to think of being very creative and innovative, these two terminologies have been a very big term that people have started to use in industry. What innovation means, what your creativity means. So if you have that interest or inclination towards that, or after that, if you are going to think anything, you have to manufacture that, which my colleague Professor Sivananda Prabhu is going to talk about the different manufacturing possibilities. So if you are going to do that, everything has to be manufactured. Thereupon, you have to see the industries are being installed. There has been continuous operation. There is maintenance, and of course, today we are talking about technology which you manufacture it, and there should be an equal demand as well as your supply. If you are going to able to match that, then there is not going to be much of difficulty in manufacturing lot of things, as well as the supply is going to meet out the demand of the customers. So if you could do that kind of engineering management, so if your interest lies in that, as well as you can see some of the slides at the bottom, we are not talking about systems only related to mechanical engineering. Probably we just talk about electrical or electronics engineering and mechatronics. Today we are talking about humanoids, where we are going to use robotics, we are going to use mechatronics, we are going to think about using your bioengineering skills. And today we are talking about additive manufacturing, specifically bioadditive manufacturing, where we are going to print organs, and in near future, people believe that if there is going to be a failure in the kidney, if there is going to be failure in any of the parts, then you can suitably replace it with the develop the additive manufacturing duplicated part. And all this is because of development in the materials and mechanical engineering. So, as I already emphasized, if you could have the strength of developing your creativity, because I'm saying it the strength, because not everybody are creative. Not everybody uses their knowledge to innovate. So if you think that you can ably convert both this creativity to provide an innovative solution, and possibly today you have great analytical tools, and if you are more skilled, you can start developing analytical tools. If you are not so, you should at least know how to use these analytical tools. By analytical tools, I mean today people think that Python is not related to mechanical engineering. People think that MATLAB is not related to mechanical engineering. People think that advanced analysis tools, something like generative design, is not related to mechanical engineering. But today, if you are going to be a mechanical engineer, you should reach to the need of the customer very fast. Let me start with a very simple example. Everybody are in the state of fear that you wanted to wear your mask, or you wanted to wear your probably the gloves. And there are gloves, there are masks which are already there in the market. Probably they are more inclined towards used by the doctors. But if you are going to use it for a longer time, and if you wanted to provide solution, you could see many of the small scale and medium scale industries have started to manufacture these kind of masks, and that is where your creativity and innovation comes, which looks attractive, which is going to be ergonomic, which is going to provide you a comfort for longer time of use. And all these things are the ones that you could find. Even Ashok Mahendra of the Mahindra of Mahindra, they started to make the ventilators. So the need is always the mother of invention. So if there is going to be a need, and if you could use all these things, then definitely you would be a great mechanical engineer. And if you wanted to be a great mechanical engineer, to be honest, apart from whatever you studied as the advanced physics, advanced mechanical, probably you know there are certain courses which are in the foundation courses, wherein you are going to be introduced about how you are electrical engineering, how you are civil engineering, how you are material science, and of course, once you enter into your second year and third year, more of core subjects on manufacturing, on design, and your thermal engineering. And towards your end of the course, probably from the 6th, 7th, and 8th semesters, even starting from the 5th semester, you are going to be introduced to subjects which are going to be more specialized. And as of today, the various bodies starting from American Society of Mechanical Engineers, our own Indian Society of Technical Education, they have large number of advanced disciplinary courses in the master's level, and at the postgraduate level, you fine tune and focus on to a particular point. So it encompasses all those things that are related to aerospace, your automotive, your nuclear. And today we are talking about all kinds of energy. And to be honest, your industrial management and economics, which your mechanical engineer is good enough, because today we are talking about three major things. If you are going to be an engineer, specifically a mechanical engineer, you have to provide the products at highest quality, at the least cost, at the fastest time, which is QCD, quality, cost, and delivery. And if you are going to come out with a greater solution with creativity and innovation, naturally, you are going to come out with quality. And these are two opposing factors. If you could manufacture products at highest quality, naturally the cost is also higher. And this is where the challenge of a mechanical engineer lies. And automatically, you should be very happy that you are going to work in a very competitive environment to provide solutions to these kind of problems and to the entire human society. So you could find some of the illustrations coming up as big as the power plants or your turbines, or you are thinking about any great substitute for your human robots, or you could see the center figure, which is going to be something where your biomechanics or the sports mechanics comes into play. Today, mechanical engineers, you are able to speak with the neurons. You are able to give a substitute to what your lost limbs could not do. Previously, it was only, as Dr. Kalam was talking about for a very long time, the greatest satisfaction when he was the head of DRDO was he was able to come out with development of a low cost, lightweight material that can be used for making artificial limbs. That is the greatest happiness that he has got as working as a DRDO chief. So, as a mechanical engineer, if you could provide, and you see today, anything that you touch upon in the modern day life, starting from the smartphones to whatever you think about, there is going to be always a part of mechanical engineering playing its role. And as we could see, I'm not just giving you statistics with respect to the mechanical engineering or engineering education within India. Globally, if you see, mechanical engineering is one of the most preferred courses. And the survey of the American Society of Engineering Education, it says even in the last year's enrollment, the highest was with respect to mechanical engineering, which is a proud thing. And you could always feel that this is going to be like the foundation. On top of which, if we are going to look at the other engineering, you can always take it and you can build upon this mechanical engineering. Today, we are not talking about interdisciplinary engineering. We talk about interdisciplinary engineering, wherein I discuss and work with a computer science engineer. I work with a biotechnologist. So we are going to use additive manufacturing technology for printing the food specifically for the military applications. So these kind of things are what driving the mechanical engineering to the next level to provide complete solutions to the entire society. And this slide you could find with respect to the Indian education, wherein slowly there is going to be a shift. Why this shift occurs? Probably our mechanical students who are presently doing their third year and final year should always take it. Also, the students who are waiting here. What may happen 4 years later, we cannot definitely assure. Probably, if at all you started this new year 2020, everybody would have given the so-called Joshe Karangal, என்ன சொல்லியிருப்பாங்கன்னா 2020 beautiful Arkuntanan. But nobody has ever even thought of this kind of virus which nobody can see it. So it is highly impossible to predict the future of the course sitting here and what would be the case after 3 years or 4 years. All the forecast is going to be dependent on how well you get educated. Today is important. If you are ready to work hard and if you are ready to make this happen today, you don't have to worry about future. And education is not about giving you an assurance that you are going to get a job. And that is not the job of the university. All that is we are going to make you a good engineer. And as an engineer, you should have the confidence to face the society, be very adaptive to the changes that is happening so that you will be able to provide solutions which everybody accepts and you will also feel quite happy by being part of that growth. And you could see from this, there is a major drop in the amount of people joining mechanical engineering, and this shifts keeps because of this alternation. Our students, when they see there is a huge opportunity in the IT sector, immediately jump to only computer science and IT. And certain times they don't even choose civil engineering. To be honest, there is so much of infrastructure that has to be developed. And you could see in this corona pandemic, the Chinese, we have heard building a huge hospital with 10,000 bed capacity in just 15 days. Can that happen in India? So if you are talking about development that is required in infrastructure at low cost and shortest time, then you have to stick on to your instincts and your core strength. So I would rather say, if you are going to think about the placement scenario, which is going to be always volatile, and it is not come out with greater achievements, which is going to give you so much of confidence to you. And to be honest, there is going to be lot of technologies that are revolutionizing, and this growth that is happening. Am I audible? Because I feel there is a small break in my internet connection. Is that
No, sir.
okay?
Now you are. Now you are. Please go ahead.
Okay. So you could see with the advancement in the computer science and technology, lot of new innovations are happening. With your smartphone, you're able to switch on and switch off your television sets, probably a remote windmill that is there in Thuthukudi, you can control it here. So if you are going to just look at reading only the people to get a job, that is never going to happen at all. You should constantly keep upgrading, skilling and reskilling continuously so that you'll be able to do things. And for that, your awareness. You should be aware of what is happening, not just only in your field, in the entire thing, starting from the basic sciences to the advanced PhD level. What are the things that are happening? Because after 4 years, you may get a job, but you are not going to be assured or least happy that you are going to stick on to a job, something which people say like a government job. Even in government job today, everything keeps upgrading, and even in universities, we are very happy to work, learn new things, go on upgrading by doing projects, and that is how we keep ourselves happy. And as we could see, this is a continuous process. Probably we talk about the industrial revolution, and you could see the inspiration from Dr. Kalam, who always say we missed the bus during the last 1990s to 2000 with respect to the computers. But today, you are not too late. Already, the advanced countries like the German or the US or the Japanese have started to work on Industry 4.0. Probably the students know what Industry 4.0. You have a virtual kind of factory. If I have a requirement as a consumer, you already have lots of related works already there. They are need not be the same kind of work, but related work. You can start looking at the database. So you have the latest technology like your data analytics, deep data. And if you could just use your artificial intelligence to come out with the fastest solution that could address to the need of the customer, then I could use the lean manufacturing process like just in time, and you could see you would be able to be the first to the market because the customer requires on time. And you see, once again, I take the inspiration from the coronavirus. It is already 6 months time, and you could see it is not a joke of coming out with a vaccine in a few days' time. It's already 6 months. But do you believe that it can happen in another 1 day or 15 days or another 1 month? Definitely not. But in mechanical engineering, if you are going to lose this, then it is definitely lost. So you are going to be already delayed by 70 days. And naturally, the industry, if they have planned to just sell a product, probably you are talking about electric vehicle technologies, which I believe both Dr. Balakrishnan and Professor Ganesh are going to give more insights. So if you are going to be into the product development, then this is the field. And there has been a kind of shift wherein you don't have to have everything in your hand. And today, the greater development in the industries, starting from the machine learning, the real-time data, all are going to help you in becoming still more bigger and bigger. So that is where your core strength has to go, and that is how you are going to think about as a mechanical engineer. And as a mechanical engineer, as I said, you have your foundation courses, you have your core courses, you also have your elective courses. So in electives, apart from just being this engineer, let me call a teacher, it's a fixed thing. But if you are going to be a mechanical engineer, you could be a purchase specialist, you could be a product designer, you could be a refrigeration specialist, you could be a kind of installation specialist. So there are lot number of disciplines that the ASME says, and as of today, there are 37 different types of disciplines that are coming up. They call it piping. They are going to have people working exclusively on biotechnology. So we have to learn what are the agencies which you are going to get your clearance. If I'm going to come out with technology where I can print the medicine, as you could see today, the level of infection for me and the level of infection for somebody else may be different. But you have medicines of fixed kind. For example, take a Dolo. Dolo comes in 250 mg or it comes in 650 mg. But the level of infection is just 150 mg. So in future, as you could find a printer in everybody's house, probably they believe in another 5 to 10 years time, people may have their own printers to print the 3D printing. But if you are going to talk about in terms of biotechnology, if you wanted to print a small Dolo machine with Dolo medicine for 200 mg, you can still do it. So if you are going to get certified for that machine, then what are the agencies? Who are the people? Those kind of things may not be possible to be included everything into your syllabus. So as a result, if you are going to go develop your skill at the end of third year and final year, you find your inclination is towards electronics, you can choose a mechatronics. If your inclination is towards working in your Gulf countries, wherein lot of petroleum industries are there, if you are thinking that you can make drones, because people today could find drone technologies delivering the pizza, that is how the Amazon and Flipkart have started to think of delivering the products in this kind of situations. If those kind of systems can be made, definitely that is where your strength of becoming a great mechanical engineer lies. So as a mechanical engineer, some of the things which I wanted you to highlight, so that if you believe that you are going to have the core interest in this, then you are going to be one among a perfect mechanical engineer down the lane after 10 years. If you have knowledge in acoustics, aerospace, automotive, biomedical, design, any design starting from product design to the biggest rocket design, energy starting from the simple renewable energy to the highest nuclear energy, which today people believe that they can have nuclear energy in the hands, which you can think that is the level at which people are talking about. Manufacturing and the complete disruptive additive manufacturing, great growth in the material science, and those people who are talking about the product design, basics of it is the mechanics, and how you can think of using your computers and electronics as mechatronics. And furthermore, we are not talking about macro systems, we are talking about nano systems, wherein we can think of using the nanotechnology starting from the materials which everybody talks about, the graphene, to any technologies for the cure of even the worst diseases like your cancer. And production planning, which is going to be the core of any mechanical engineering manufacturing. And to you do that, we have the places where we can use the robots and for complete installation, your thermal analysis and your structural analysis. And I'm just going to give you a fair idea because this is going to be the scope which this entire country is talking about. Those days we had cars, and today we are talking about cars where even the road noise is not even being generated or not even being transferred to the occupants. We are talking about no or nil vibrations. So the noise, vibration, and harshness, as well as the development in the materials for your wheels, for your braking, and the vibrating systems of your power drive are the duplicated ones or the replaced ones of your IC engines. Today we are talking about the electric vehicles or hybrid vehicles, which can totally be eliminated. So if you are going to talk about the acoustics, what are the materials that can be used? And we are talking about lightweight materials, and that should also be structurally good. So if we are going to develop new materials, it is not that we are going to come out only with the composites. We are not going to always think about natural fiber composites. We could recently find a great material which is very lightweight, more superior than even super duplex stainless steel, that are collaboratively made by US University and IIT Madras. So if those kind of things are to be thought about, or if you are going to come out with materials, and you could see there have been world records of building 40-floor buildings in less than 15 days by the broad construction of the Chinese. So if they are going to make up earthquake-proof buildings as tall of more than 200 floors that can withstand an earthquake seismic of more than 10 Richter scale, if those kind of things have to be there, so that is where the challenge lies. And if you are going to talk about aerospace, look at the great inspiration that people like the Tesla, they are thinking about. Starting from 2006 and 7, they have been thinking of reusing the rockets. Why you have to once again create new rockets? So Elon Musk had the greatest vision to have entire city that is going to be there in the Mars, and doing so, how people can go, escape, and come back. So they have already made successful products and proved that in 2018 and 19. So associatively, they were able to come out with how the energy can be stored. Is it that we have to use only the lithium-ion batteries? Is it that only we have to use only the metal-ion batteries? Why not we have something other fuel cells? So if you are going to think all those things, then what kind of materials that are there? What kind of propulsion systems? Should it be only, as we are talking about, VLSI, VLSC? So many other things that are being spoken about can give way to every one of you to think big and use your basic physics of coming out with an engineering product so that that can be converted to a technology in the future. And with respect to automotive technology, I just have to give you a fair idea. We are talking and heard about something called autonomous vehicles, wherein just your voice is good enough. You are going to specifically say where you wanted to go. Your GPS system, which is taken care by the civil engineers as well as your computer engineers, is going to give you the shortest route with the least traffic. Your car, it is going to brake itself, start itself, and keep moving from one place to another place autonomously. Just your voice is good enough of making the entire vehicle move. And if this is going to be the case, you should know how much of electronics is already there. As of today, if you could think, more than 70% of the components are going to get the feedback. And you could see most of the cars that are recently launched are going to have a lot of features. And we people talk about value for money. And today, the customer requirement is what was once upon a time considered as a luxury has become an essentiality. There is no car without air conditioner. There is no car without your airbag. Those days they were considered as luxury, but today they are a necessity. And all these things they wanted to have, as I used to always say in the class, there are people who expect all the features that are there in a luxury car, be it a Volvo or a Mercedes-Benz or an Audi, at the price of a Maruti. So if you are going to do that, how you are going to do that? To be honest, it is possible. And if you are going to work on that, that is going to be made possible only if you are going to know about the different aspects of the product as a mechanical engineer. And no other engineering could definitely give that, as I can very confidently say, this is the versatile engineering and one of the oldest that is still relevant to every aspect of a human life. And I am just going in the alphabetical order. With respect to the biomedical devices, people talk about biomechanics. Today, your humanoids, your exoskeletons, all these things are going to replace, and the way we are going to get treated, probably a doctor need not be physically available. As you could see in this pandemic, people are able to give the webinars and people are able to diagnose, and the machine, if you are going to just go, you can even have your expert opinion even from abroad country. But what I'm talking about, you can have the complete thing at the least weight, better materials, which are biocompatible materials. We are talking about biocompatibility. Those days, very few materials starting from titanium or gold were considered as biocompatible. But today, we are in the process of developing many biocompatible materials. As I was saying, it is not just limited to orthopedic or dental, as it has been widely used today. In future, even your kidneys or your lungs or your heart, people have already started to work on the mechanics part of it, the materials aspect of it, and have already printed and trying to make trial tests. But still, I strongly believe in another 10, 20 years, larger industries in the advanced countries have worked. And this is where, if you are going to work as a mechanical engineer, in the near future, after completing, you should develop your core strength and skills to be relevant so that there is still scope as a mechanical engineer. And with respect to design, today we are a design which is totally disrupted. What can be made with conventional manufacturing process, with even the advanced CNC machines, it is becoming irrelevant. Those designs where we don't have any design data, probably 300 years old, we don't have any design data. Or if you wanted to have the same thing manufactured in a different way, then it is going to be only the additive manufacturing, which is going to come because of the development of CAD, which is nothing but computer aided design. And we also have the computer integrated manufacturing and computer aided manufacturing, which is going to join hands in hands. And we have the flexible, your FMS, your flexible manufacturing system. So once you are talking about the need of the customer, I just wanted to have a lightweight for this weight, whatever be the case, then automatically today we are talking about generative design. You have heard about certain things called the Google Lens. So you are just looking at it, and automatically the augmented reality, it gives you the address. And if you are going to see in your Google map, if you are going to see the Google map, it is able to give the names of the places as well as the address in a three-dimensional view. I am not joking. You just try to use your Google map, you could see the three-dimensional figure of your home in your Google map. So that is how the computers have been totally adapted into the product in your day-to-day life. And even in design, I don't have to redesign the entire thing. But if you have the knowledge of selecting which is the best one, then the CAD tool automatically generates as many number of designs for me. And my core strength is to select which is the best one. As I was talking about, it should be manufacturable, it should be at the least cost, and it should be having value for money. If these three things are going to be addressed, naturally, we would be able to not just provide solutions as you think only for those things that are in motion, but also for those things which are going to be inside the body. And talking about energy, you could see those countries which are not having too much of wind, those countries that are not having too much of your solar energy, they are working on the advanced levels of energy, wherein floating wind turbines, they have your complete solar system which can produce in megawatts. They have such big farms of your solar system. And if you are going to look at it, the efficiency of the solar system, your photovoltaic cells are not too high. And if you are going to be interested, you can start working on developing new materials, come out with identifying the process of eliminating the losses so that you can come out with higher efficiency systems that can be coming out with not providing solutions for the needs of your energy, but also be additionally or augmented to some other fields like your automotive, where you could see the people can use this technology to have a complete green energy revolution. And people still believe that IC engine cannot be duplicated or replicated with an electric vehicle in the future. And electric vehicle we talk about, and it has its own demerits. So the carbon footprints that it is living by the use of lithium ion, if you could look at the research perspective, it is still more detrimental to the environment. So if you could look at developing the energy solutions, be it conventional, be it nuclear, be it hydroelectric or anything that you're talking about, not only generation, but also your storage systems, then definitely you are going to be relevant. And with respect to manufacturing, I've already given you more impetus on the additive manufacturing, but today we are talking about industrial Internet of Things and automation. Though you are going to be given introduction in your basics with respect to how your computer integrated tools are working, how your human layer is totally eliminated and you are going to have completely automated assembly lines, something like that. But still, who are going to give solutions for the future for the virtual manufacturing? How you are going to use the high speed? We are talking about 4G technology. Already the 5G is there, and there are two smartphones in the Indian industry, even your low-cost Xiaomi or your OnePlus have come out with the 5G technologies. And your hardware manufacturing and how you are going to, and as I was talking about, you are going to have design for enhancement. So does it mean that once the 4G comes, 5G comes, the 4G machines have to be totally thrown out? No, you have to see that there are ways of how you could extend its lifetime in the day-to-day life and into the industrial use. So you are going to see these kind of design for enhancement possibilities. So as a mechanical engineer at the undergraduate level, you would not have thought of all these things by just learning only the subjects that are being given as core subjects or your elective subjects. So this is where I say you should start looking at as a scope for mechanical engineers and how it is relevant to the 21st century. And with respect to the materials, I have been talking about more commonly used terminologies like the natural fiber composites or your advanced composites, your metal matrix composites. But today we have functionally graded materials. We have shape memory alloys. So the SpaceX of Elon Musk, they are trying to use the space memory alloys. And we are talking about the advanced nanotechnology tools of using, as I already mentioned, graphene, not just for providing solutions for different needs of the various industries like the automation of the robotics or in your automotive for your other things, but also for the bioengineering, where this kind of small materials that are developed, and there are so much of analysis being done. As materials engineer, you think that it is only the basic science of materials that you are learning about. But today, your tools, which even the TCS, I appreciate our colleague, Professor BALASIVANANDHA Prabhu, he is working closely with some of the major giants of the software to develop, to see how you are going to have these nano tools or the nano materials functioning at the final product level. So they are simulating it with the development of new tools with support of the design students. And anything that you are going to use, you are going to see there is going to be a failure and how it has to be used. So if it is used in a different way, there is every possibility there could be a failure. And if there is a failure, should we go for complete replacement or can we go for repair, which we call it as repair and maintenance. And doing so during the new product development to the requirement. You could make cars with even more than 300 bhp running at even 200 miles per hour. But what is going to be the material in which your entire drive system is going to be made? Or if it is going to be your front pre-tensioner belt that you're going to use, what is the force that you're going to use for clipping in and taking it out? Or for that instant, you are going to have the water coming up in the cans. Suppose if there is a drop, what is the weight that it can take up, from which height it can be comfortably, if at all there is a failure, it can take up. So your basics of mechanics, you are already introduced in your 10th, 11th and 12th standard itself, but at the advanced level, we are going to introduce with respect to your solid mechanics, both at the static level as well as in the dynamics level, into the fracture concept and substituting it with not your simple calculus and all those things. So we are going to use your numerical methods, try to use your simulation tools like your analysis. I don't want to mention the name. So we call it as finite element analysis tools. There are n number of finite element analysis tools which we are going to use it. And as a mechanical engineer, you should not just stop with studying the tools that are being given in your undergraduate level for just your modeling, for your analysis, or for your projects. So you should see what are the tools that the industry is presently using. Most of the tools they generate by themselves in-house. Suppose you are going to listen to the lecture of Professor Balakrishnan, who was here the professor and now with the Caterpillar. They are having their own tools of simulating these kind of failures. And all that is to understand how your basic tools are generated. So if you could understand how to develop the finite element, those what we call it as the elemental matrix, all those things, you may study that as a tougher subject. You just wanted to pass, but that is not you have to look at. As +2 students, you have to see, use your strength in your physics and mathematics to develop further and further and see how it has been relevant to the industry. And I believe the industry people who are going to join later would be emphasizing on this a lot. And with respect to thermal science, you could see, I will just take once again the example from the smartphones. You could see during your charging, or if you are going to use it for gaming for a very long time or speaking for a very long time, you could see that smartphone is getting heated up. So when there is even a flow of whatever you see, what you cannot see, the electrons, there is going to be associated heat energy. You have to see all those things are at the small level, which are, we call it as micro electromechanical systems. Even at that level, you should see how this has to be dissipated so that your efficiency is not deteriorated. You are going to have the productivity life of that particular component or your product for a longer time or a stipulated guaranteed warranty time. So that is a huge discipline of mechanical engineering, wherein the study of the generation of energy, how it can be dissipated, how it can be stored with respect to your heat exchangers, your boilers for your power generation, all those things are what there in for a very long time. But today, as I was talking about the inspiration of SpaceX, once you escape from the environment and come back, you could see when escaping, it would be going even to the sub-zero temperatures, which we call it as cryogenic. When it comes back, it once again re-entrance at a very high temperature, more than 1400, 1500 degrees. So if there is going to be shift of temperature, and the greatest example which was known to everyone was the failure of your Titanic ship, which is accounted to ductile to brittle transition. So if you are going to develop new materials, it is not just you have to know only the thermal science, but you have to understand this thermal science with respect to development of materials and how we can manage the thermal management. So if that is the thing that you are looking at, definitely you are going to still become relevant to the industry. I was talking about the use of electronics, use of computers in the development of the integration of mechanical systems, and the terminology most commonly used is the mechatronics, where your mechanical systems is getting integrated with electronics and computers. And today we have the internet playing a major role. So you are not looking at creating these kind of robots for your manufacturing or industrial purpose. But today we are talking about using these robots in the war field where people cannot go. You have micro drones as small as flies. They are just weighing in few grams. They are using this small micro drones to go to places where there is going to be an Naxalite operation, where there is going to be a chemical explosion. Recently, you see, because of reopening of industries, even in Visakhapatnam or in Telangana, or even in Tamil Nadu, there were explosions. Suppose if the chemicals have grown and you are going to see it is deteriorated the environment, then these kind of tools have to be developed. And you should remember that is the need of the customer, that is the need of the industry. So if you are going to come out with products, then that is how you remain relevant totally. And you have studied many management tools. We are going to completely plan the production, your design activity, or even after entering into the consumer space, how you are going to have this extending its product lifetime. So the terminologies like enterprises resource planning, advanced planning and scheduling. These are the terminologies that the industries use so that your industry 4.0, you are going to do it on time with best solution to the need of the customer. And the tools that I am talking about, it is going to aid you in forecasting the demand. Just to give a very simple example so that you can relate, there are big names like Walmart. Since Walmart has been already known in India, I'm just saying, suppose if Walmart is interested to have a new store in one of the developing cities, all that they take is the help of the Google, where if at all you know, you start searching in the Google and you would find if you keep researching that, naturally the engine pops up with related news items for you. That is because of what is called as artificial intelligence and data mining. So your Flipkart or your Walmart would be paying the Google to identify if I am going to establish a new mart in that particular location, how many people are interested in the various products. There could be millions of products in their Walmart. So they would understand, and accordingly, if 10 beds are required, they would be having only 11 beds. You cannot have a large amount of resource in your stores. You could find a latest news. The greatest Amazon store in the California was completely burned out because of the fire. So you should not have lot of inventory. So you should have the inventories just to the requirements. Your supply and demand should always be moving online. Then only you'll be able to plan your things. So those kind of things are the ones not studied only at the postgraduate level by the management students, but also as economic aspects, as your planner, your mechanical engineering is given some amount of idea too. And just to summarize up, do you think that whatever I have been talking about, the entire mechanical engineering is changing its profession? Definitely not. But it is been becoming more responsible. It is seen as a more needy thing for every engineering. You could see the most advanced car, at least 70% of the people know. You could find 70% of the products that are there on the car, everybody know you can get a feedback. You could see the advertisement that comes for one of the most common cars, the Kia Seltos, wherein the moment the child or whoever it is try to go, immediately it switches on. I'm just giving a commonly known example because it can be switched on from a remote place. So what was once considered a small introduction, once upon a time you had the ஒரு மாருதி கார்ல ஒரு அடிஷனல் எக்யூப்மெண்ட்டை நம்ம ரிமோட் கீயை வைக்கும். இன்னைக்கு பாத்தீங்கன்னா ரிமோட்ல உங்களுடைய ஸ்மார்ட் போன்ல இருந்துட்டு யூ கேன் சுவிச் ஆன் அண்ட் சுவிச் ஆஃப் யுவர் கார். You can switch on and switch off your air conditioning of the car. You can open your windshields. So if this is going to happen, then how you are going to make it? How you are going to make this smart? How this is happening? Because the computers, the use of your artificial intelligence, the use of your R&D in your generating new designs, you could see the graphics, the same chair, you can make it in different ways. Which is going to give you the best design, which is going to be least cost. All those things have to be taken up. So if you are going to be a relevant person to the industry as a mechanical engineer, then if you are inclined towards, then start learning the advanced tools. We are talking about the commonly known Autodesk products, but even that Autodesk products have gone to using this generative design. They have their own product. So you start learning those kind of tools on your own because every advanced software tool are giving student license free of cost at least for a month's time. You start using those kind of tools. And as I was already mentioning about your robotics, they are completely replacing the industry where every product you could be least assured in future. You just introduce the raw material. It may come out as a final product without human interference at any point of time. And that is what is moving towards in the industry 4.0. And your mechatronics, there is a large scope. So apart from just being the person who can use only the toy tools, you start using your advanced tools of your MATLAB and Python, start developing your own robotic and mechatronic tools. And as I was mentioning, today the additive manufacturing, every aspect of additive manufacturing, starting from making small parts, be it a toy for a kid or to completely come out with less weight, more superior product for the future with a beautiful cost which nobody can imagine about. That wow factor, this additive manufacturing is where it is making a total disruptive thing, which I believe Dr. Sivanand Prabhu would also be touching upon. And to be honest, within few years of and year on year, within 2 years, you could find almost what was only used for 27%. Today, even 52% of the production parts are made using your 3D printing. And every tool that you are talking about, or every discipline of mechanical engineering, be it even in civil engineering, there are uses of your 3D printing in civil engineering. Just look at the open source videos and research articles which are giving how this additive manufacturing, which is core of mechanical engineering, you can extrapolate and use it in civil engineering. You can extrapolate and use it in electronics engineering. Definitely, you would be more relevant. And you should also have a idea. This is what called as Gartner's chart. So Gartner is a kind of a simulation which is going to give you, if you just look at this, they project with respect to different technologies when you are going to have the plateau reached. You could probably relate. The COVID, they are saying it is increasing. Once it reaches the peak, then it is going to come down. So you are going to have for the different technologies. If at all, just look at the nanoscale 3D printing here. So I am talking about 3D printing, but if you are going to think about nanoscale 3D printing, it is still more than 10 years to reach. So if at all you are going to start your engineering or even you are in the final years, if you are going to work in the area of not just 3D printing, but nanoscale 3D printing, I am talking about a technology called 4D printing. Have you heard about it? It is not just 3D printing. Today, people have gone to the next level of what is called 4D printing, where your shape memory alloys are going to be printed using your additive manufacturing, and you can change its shape. So if you could print 3D printing at the nanoscale, it is still more away by at least 10 years, even in the advanced countries. So if you could become relevant of providing solutions to 4D printing at the nanoscale, you are going to be the biggest entrepreneur in the next few years. That is the assurance I can give you today. And talking about finite element analysis, I was talking about the analytical tools. So you are going to not make crash testing of every car and give a rating. So if you could think of the various links that are there, the various structures that are used in, probably I have taken an example of a F1 racing car, then you have to have the least drag. Probably if there is a crash, it can tumble down, but there should be no hurt to the occupant, the driver. So if you are going to use, then what was once not possible, or what was you are using only the mathematical tool to do it, today you are going to have everything simulated virtually by using your finite element analysis tools. So if you could use that, as I was already mentioning, my friend from Caterpillar would also be giving throwing the light. They develop their own tools. They are not going to use the so-called branded names like a ANSYS or Abacus. They have their own things, because developing it, you have to know your FEA very strongly. Then you can learn it. So Those are the things that you should look at if you wanted to choose your design engineering. And Internet of Things. So we have been talking about technologies like machine data, artificial intelligence, Internet of Things, Internet of Things in terms of the industrial Internet, and of course, we are talking about smart industry. And all these things were the elective subjects previously for the computer science students, but today it is not so. We have to start learning, and of course, we are having something called as open elective introduced in your choice-based credit system. For the students who are in the final year, they may be willing to learn these subjects. And if you have not learned it, if you are going to augment yourself with this technologies, then you become industry ready, because the industry is not ready to hire you, train you, and then use you. They wanted to use people who are industry ready. I am not talking about with respect to your technical skill. I am not talking about with respect to your communication skill. I am talking about with respect to how well you are going to have your skill that is required for a particular industry. So your resume development itself should be different, because your 21st century hiring may not be with respect to one-on-one interviews. It is going to totally get disrupted. And from the placement scenario we hear, the industry do not want people who are just having a particular skill. They are the people who are looking at, if you could provide solutions to a most crush area, which is developing, which is at the threshold at shortest time, they are the ones who are going to get absorbed. So for the people who are in the plus two, I'm giving you a word of caution. Don't think that you are just escaping from the school life, entering into the college life, which is going to be still more attractive. Just have your fun, as you could see from what you hear from the media, from the cinemas and all those things. And even these 4 years that you're going to invest, remember, what you do today is what you're going to reap tomorrow. If you are going to develop, I'm not saying that you should not have your extracurricular skills. You are not supposed to develop any other things, but you should also have real interest of learning and augmenting all the skills that we have been talking about, what was once seen, nowhere related to mechanical engineering. So your mechanical engineering industries, there are majorly with respect to piping industries, which are both your chemical as well as your petrochemical industries, your automotive industries, which are going to use future technologies of IoT, your data and all those things, and your original equipment manufacturers. Those people not only look at the key terms that I've given it, be it your additive manufacturing, be it your advanced design tool, but are also going to look at certain skills. So you should get augmented to that, which I believe my friend Dr. Samuel Raj is going to give insight about what are the additional tools you should get acquainted with, so that you become industry relevant. And just to conclude my topic, so those students who are in the final year, do you believe that your engineering degree is good enough? I would only say, if you are going to believe that, then I would say it is only 30% of what it is. It is something like opening the key. But today you are going to also have your biometric along with opening your key. So you should have those kind of things. You should constantly keep yourself upskilling. You have to constantly keep reskilling, so that you know today your workspace is not always going to be steady. It is going to be totally disrupted. What was taking 10 years of time for making a change is happening in just 1 year or 2 years' time. My friends, I'm not discouraging you. If you are going to know about it, you should accept the challenge. Be willing to work towards that by learning new things. And your age is going to permit you to learn faster and fastest. And only the fastest is going to remain relevant to the future space. And if you wanted to be one among the people who believe that the society has not given you, the college has not taught me, the syllabus is irrelevant, then I am really going to give you a shocking news. It is not others' fault, it is your own fault. So you start accepting that it is not a 4 years of jolly life. It is going to be a life wherein you are going to sow your entire நீங்க இன்னைக்கு உழுது இன்னைக்கு உரம் போட்டு இன்னைக்கு போடுற விதை தான் உங்களுக்கு 40 years of your fruitful life is going to be in front of you. And even those people who have joined after completing your BE, I am giving you a positive thing. It is not too difficult to find a job. Only thing is you have to always keep yourself working towards the needs of the industry. Look at the whatever the possibilities, the scope that is there around you, automatically you will find. And as I was talking about, your creativity and innovation of providing the solution to the needs of the customer is what today requested. And if you could augment that skill, I would not say anything is impossible. Everything is possible. Thank you very much. And after the complete lecture of all my colleagues and the industrial experts, I would be happy to take up the question and answer. Here comes my Gmail ID. If at all anybody is interested, you can think of mailing me later personally into my email box. Thank you very much.
Thank you, sir. That was really an eye-opening as well as inspiring session or talk that you have given. Actually, it was like, I mean, as a biologist, even I was like, I mean, very much into your talk. So covered almost all the aspects, it seems. Let's see if something you have left for the other speakers also. So without wasting any time, I request Professor S. Balasivanandha Prabhu to deliver his address. He is currently a professor of mechanical engineering at Department of Mechanical Engineering, Anna University, Chennai. His areas of research interest include manufacturing engineering, composite materials, and nanostructured materials. He has contributed 6 book chapters to Handbook of Nanotechnology and a special volume of Aluminum Lithium Ions, Alloys, and Severe Plastic Deformation. He has authored more than 160 papers in international journals and conferences. He has filed up to 3 patents in the field of cutting tool development. He has published a book on superplasticity published by Springer Nature. He has also completed 2 sponsored projects funded by DST. So with this brief introduction, I request. Sir, please.
Thank you very much. Very good morning to, good afternoon to one and all watching the webinar session on net. And thanks to Mrs. HEMAA, Senior Scientific Officer, and Professor Muttamalarasan, and also Professor Radhakrishnan, and all my colleagues at Anna University. And I think Professor SHANMUGA Sundaram has touched upon all the points of mechanical engineering. And now I'm going to talk about only the opportunities in manufacturing sectors. And before going to the opportunities for mechanical engineering engineers in the manufacturing sectors, let me explain what is the composition of our mechanical engineering subjects for understanding.
Papa?
Sir, it seems your connection was interrupted. Can you please begin from the beginning, from the starting?
Yeah, now I think it's I can be able to hear you.
Yeah, right now it was fine. Previously it got stuck.
Okay,
In your
now
first
can
slide.
we proceed?
Yes,
Can
sir.
I
Please.
proceed?
Yes, sir. Please come from the beginning. Yeah. You have to share your screen.
I have to share my screen. Okay,
Yes.
okay, okay.
Yes. Thank you.
Now is it okay?
Yes, sir. Now it is fine. Now it is fine.
Okay, okay. So why mechanical engineering? Always know there is a question rise during the before admission. Always know students as well as the parents used to ask why mechanical engineering? What are the job opportunities? Oh no, after graduating mechanical engineering. So there, mechanical engineering, it's a evergreen branch. No, like other branches, no, unlike other branches, the mechanical engineering growth would be very slow and steady. It would be slow and steady, but you have definitely the opportunities in core sectors. Okay, in mechanical engineering, the students will be studying something about the design development and manufacturing of engineering components. So in our curriculum, mechanical engineering curriculum, no, the composition would be design and manufacturing, thermal and energy and management. So here the limited number of credits will be also there for humanity sciences and management courses. And also we have a little amount of basic sciences also, like physics, chemistry, and mathematics. That would be around about 25 credits. Then we have engineering science courses where people will be also studying essential other branch courses like electrical engineering, electronics engineering, computer science and engineering. That will cover, that is a necessity basically for mechanical engineer. Therefore, the basic courses will be also covered in our syllabus. Then we have a professional core courses. That will be a major amount of courses where the people will be studying the core related subject related to design, manufacturing, thermal and the energy and management. Apart from that, we will also have a professional elective. Here, depending on the interest of the students, one can select. Now we have a choice-based credit system in which the students can choose the elective. So supposing if the student wanted to particularly go for design-oriented job opportunities, then probably they can select design-based elective subject. Supposing if the students are interested in only for mechanical engineering, manufacturing related core industry, they can also go for manufacturing related subject. Therefore, here the flexibility is given to the students. They can pick up their own subject based on their interest and based on their the inclination to the career path. They can choose always knows the subject, professional elective courses. So we have about 18 credits. So there will be a little variation in the credit system between university to university. Then we have open elective. We can also select the other department courses also based on the interest. Supposing now the mechanical engineering student has to study other subjects also, something like data sciences, something like the computational software, something like, so the other department course is also mandatory nowadays. Therefore, they can select some open elective courses from other departments, and also employability enhancing courses, something like project work, and also other soft skill based courses that is also offered. So the mechanical engineering syllabus, our curriculum is comprised of this all the segments, but there would be a variation, whether university to university, there would be a variation in the credit points. Now here, what are all the opportunities? So after graduating mechanical engineering, you have good opportunity in government sectors that you should not ignore. So you should not only look after only the opportunities available in non-government sector like private sectors. There are a lot of opportunities available in government sectors, especially in railway, integral coach factory. So there they are fabricating or manufacturing the coaches where the mechanical engineering role is very, very huge. And then Bharat Heavy Electrical Limited, BHEL, there where they are fabricating boilers, heat exchanger, steam, tubes. So, and also there is an opportunity for welding inspectors position there. Then we have a defense and production units, and probably in future we will have a lot of the defense and production units in our India. Okay, there will be an opportunity for a mechanical engineer. Then we have a number of CSIR laboratory. The CSIR laboratory dedicated for some laboratories are dedicated for glass and ceramics, something for dedicated for the composite material and material research. So a lot of opportunity. So even if you are going with the BE, you can also go to the entry level as a scientist. You have a huge salary package. Then ISRO, there is an opportunity. for a scientist position. And we have a HAL and NAL, Hindustan Aeronautical Limited and National Aeronautical Limited, where the mechanical engineering opportunities are very huge. People has to realize that in government sector, you have a lot of opportunity. Then central manufacturing, machine tool, manufacturing, machine tool related R&D organization. Then you have a process industries, huge process industries that are government supported process industries. Then welding research institutes, then oil and refinery industries. Then particularly many undergraduate students ignore this IES. You have an opportunity in IES, Indian Engineering Services, where if you pass this IES, you can be a senior section, senior engineers, or sometimes assistant manager, assistant directors. You will be directly employed. You will be skipping 3-4 levels, and then you will be directly employed in those categories. So huge opportunities. But one thing you have to do is, from the second semester onwards, if you are looking for IES opportunity, from the second semester onwards, you have to keep on work. Apart from the regular classroom activities, you have to keep on read the textbooks. You have to keep on solve the problems. And we have also opportunity in NLC and IOCL, National Lignite Corporation, Indian Oil Corporation Limited, and so many opportunities. The opportunities I have listed here, it's only very few. But apart from that, you have also opportunities in state government sectors like PWD, Public Work Department, and other departments also. Therefore, these government opportunities are nowadays possible if you have a high scores, and also GATE. Most of these industries, R&D organization, are probably this government sectors nowadays. Recruiting the people through written process, written examination, and also you must have a valid GATE score. That is a pre-qualification, pre-necessary qualification to enter to a government sector, because this GATE is now necessary. It's something like a visa for you to admit yourself for an examination. Therefore, you can also start prepare for a GATE examination from the second semester onwards. So apart from this government sectors, you have also non-government sectors, starting from automobile industries, power and energy sectors, and also you have chemical industries, food industries, glass industries, textile industries, and you have consumer good industries and metal manufacturing industries. So many industries opportunities are there. Now, when you talk about the manufacturing industry, especially the private sector, you can group this manufacturing industries into two sectors. One is the assembly industry, another one it is a production industries. So the assembly industries are high-end industries. They never
It seems there is an interruption with the connection of Professor Prabhu. We can wait for 1 more minute to see if the things are getting resolved at his end.
Hello.
ஏன் அவரோடது மட்டும் அப்படி ஆகுதுன்னு தெரியல. வேர்க்குதுமா.
Sir, Sundaram, sir.
Yes, sir. Yes, sir.
Sir, can you please advise how to proceed with this?
Probably we can request the next speaker to join, sir. No problem.
Okay, sir. But now Prabhu sir is back. Sir, Prabhu sir.
Yes, I am Prabhu.
Yes, sir. Like, I mean, will you be able to continue?
Yes, I think there is a disconnections, interruption in my internet connectivity.
Okay.
I will go through it. I will quickly finish within 5 minutes.
Yes, sir. Please.
Okay. Okay. So I think I have interrupted here. So the manufacturing industries we can segment into production industry and also assembly industry. In the assembly, we are going to assemble the component which are fabricated by a small scale or medium scale industries. Where if you take a car, a four-wheeler, where you have about 30,000 parts are manufactured. 30,000 parts are manufactured by small scale industries or medium scale industries. These will be transferred to the assembly industry where this will be assembled. Therefore, 30,000 parts, you have to imagine this in terms of opportunity. You have 30,000, probably the near equivalent companies, they are manufacturing these individual components. So the opportunities are very, very great for this manufacturing people here. So generally in the manufacturing sectors, you have the industry that can be classified into 4 sectors. One, forging industries, casting industries, and machining industries, and welding industries. Now, these forging and casting industries are a backbone of our country because they are giving a major share to GDP growth, and the forging industries are really spread across our nations. Now, you have in southern region also some of the forging industries, and we have a number of forging industries where our share is very huge. Now, you have probably 59% of very small scale industry and 24% of small scale industry. These are the opportunity providers to our BE graduates. Okay, and we are the number in the world rank. We are the topping in forging component productions, and these forged components are majorly used for automotive industries. The original equipment manufacturers, automotive original equipment manufacturers, they are outsourcing component to forging. So the forging is one of the forged components are one of the prerequisite for manufacturing the assembly process. And the next industries are basically casting industries. Actually, we are number 3 casting producers in the world. Okay, so the Brazil and other peoples are ahead of us, and we have the capability 13.38 million metric ton capability here in India. So that is spread across the nation, and we have clusters of casting industries in Chennai and Coimbatore and Belgaum. If you take the clusters, each clusters are dedicated for its own components. For example, Chennai and Belgaum, they are fabricating the component for automotive industries, and Coimbatore clusters are contributing for pump-based industry. For pump, the outer cover and everything is fabricated, produced by casting. And apart from this, we have many top-ranked casting industries like Lango Industries, Hinduja Foundries that is available in Chennai, and Ennur Foundries, which is a known foundry, and Wellcast Industries, and Kirloskar, Ashoka, Mahendra, Hooper. So these are some industries, and there are large number of industry, but I have limited only to this. And also, if you look at the segments or consumers, and a lot of these industries are producing component for automobile sectors. And there are, apart from automobile sector, there are other sectors also like railways and powers and vessels and valves. And majority of this casting industries are producing cast component to automobile sectors. And these are some of the component I have produced, you can able to fabricate even a massive structures out of this casting technology. And these are other industries, well-known industries. Okay, Nelcast, Brakes India. The Brakes India is available in Chennai, Hinduja Foundries, Tata Motors, and PSG Coimbatore. And you have wide opportunities in the casting industries also. And apart from this casting industry, and now we have a welding process and inspections. And actually, there is a great demand for welding, qualified welding inspector. Actually, this welding inspector is a qualified certificate program offered by American Welding Society, where it actually, after this BE program, you have to separately undergo a training program and followed by examination process in which you will be awarded the qualified welding inspector certification. And that is necessary to work in these kind of industry, supposing if you choose the welding as your path for your career. The welding opportunities are available in aerospace industries, automobile industries, infrastructure, especially L&T and other infrastructure industry, a lot of opportunity, and pure manufacturing sector, railroad, shipping, marine industries. They are looking for qualified welding certified inspectors. And this American Welding Society is offering that course and also offering the certificates. Apart from that, you have also the opportunity for welding related works in auto industries, chemical industries, electronics industry, and engineering industries, gem and jewelry industries, leather industries, textile, water, mining, and their contribution is very greater. So apart from this, all these core industries like forging industries and casting industries, welding industries, really we have a process industries, steel production industries. India is top ranked ranking in steel production and ferrous and non-ferrous metallurgical production. So for example, here we have a list of companies. They are producing good quality steel: Tata Steel, Jindal Steel, SR Steel, Vizag Steel. These are some of the leading companies. SAIL, for example, SAIL. So we have good companies where the greater opportunities are there for mechanical engineering. As Professor SHANMUGA Sundaram pointed out, the core industries would be there for another 30 to 40 years, but the future industries would be Industry 4.0. And the Industry 1, it is based on the mechanization and steam power and water power. And 2.0, it is based on the mass production concept. And the 3.0 is basically partially automation. And now here it is a cyber physical interaction system. That means the industry would be there. The industry would be operated through cloud. And even during a lockdown period also, you can able to operate the industry through clouds. Even sitting at the room, you can able to operate the industry and you can able to produce the component. So that is the concept. Now people are moving toward this concept. So this is a future industry, Industry 4.0. For this, in addition to your regular mechanical engineering subject, you should be also thorough with data sciences, artificial intelligence, and cloud computing, and industrial IoT, Internet of Things. So these are combined together, and you can able to also work on Industrial 4.0. Okay, so for that, now you have to have how to cloud computing, data science knowledge is also mandatory. And another area really undergraduate students can work is virtual manufacturing. So before manufacturing a component, one can able to see the component virtually. And it's not only the component, you can also virtually see the process, and you can see the product, and you can also see the assembly operation virtual, and you can also see the flow line also virtual. Example, if I want to see how the casting component will be after my casting, I can also simulate the casting. And forging operations, I can able to simulate. Well, during the forging operations, I can able to visualize the defects also, the casting defects also, and I can work on eliminate the defects by control over the process parameters. So this and all, it's a nice opportunity where people can work. For that, the software knowledge is very, very essential. So you have to learn virtual tools also, which are important for manufacturing related subject, like the casting flow software, for forming softwares, and the computational simulation software, and welding related software, and the assembly related softwares. These softwares also, in addition to your regular courses, if you study this, then probably you have a nice opportunity, career opportunity in this also. Now, before I close my session, I have a specific tips for enhancing employability. Actually, this slides I have taken from a talk of Professor T. Tyagarajan, is a dean of our MIT campus. And in the initial period of your undergraduate program, probably second semester or third semester, you have to have a frequent industrial visit. So in the beginning of your career, beginning of your undergraduate program, you have to visit the industry and what are all the activities are going on in the industry that you have to really see. And then once you come to fourth semester, fifth semester, sixth semester, you have to go for a implant training. You work for implant training for 2 to 3 weeks or 4 weeks and then learn something and obtain some skill, improve your skill, and you can share, you can get the knowledge from the workers, you can get the knowledge from manager by means of implant training. And other possibility is you can go for internship, a 2-month internship, 1-month internship. The internship opportunities are now wider in industries. If you go and talk to them and then without any money, I can work for internship for 1 month, they will ready to give you. So during this internship, you can be able to really attract the industry people. Therefore, the one opportunity you can learn what is going on in the industries and what are the tools that are being used in the industry that you can be able to understand. And also, if your work is satisfied, then probably you have a nice opportunity in future also, the industry can absorb you. So internship, it's a way for getting employment in the industry. So internship and then mini project, as many as possible mini project you can be able to do. So in order to improve your skills, documentation skill and research skill, and then paper presentation. Whenever you have a possibility, you can go present the paper. That will improve the communication skill. And also, apart from your regular courses, you can also study the value-added courses like Internet of Things, 3D manufacturing, additive manufacturing, Industry 4.0, cloud computing, and then welding inspection, non-destructive evaluation, these kind of courses. Now you have a value-added courses available online. NPTEL is offering so many courses. And also there are many online course opportunities are available. So without even any fee, you can be able to study this, but for examination, you have to pay the fee. So that opportunity is also available. Then value-added software like product life cycle management, CAM-related software, CNC-based software that you have to say. And also very importantly, during your undergraduate study, at least you study one foreign language like German or French. So any foreign language and improve your soft skill. Finally, the student must remember this acronym, that is FACTS. The fact is you have to clear all your subjects in first attempt. F stands for first attempt and you should have a foreign language. Then A for good attitude. You should have a positive attitude always. Okay. And then C is a communication skill and creativity. Engineer needs to be creative. So creative thinking and lateral thinking, and also you should have a communication skill. And then think positively. Always know you should have a positive thought. Okay, no second thought, no negative thought. Then S stands for sagacious. That means you have to exhibit your talent. So the moment you exhibit the talent, you have an opportunity, wider opportunity. So the FACTS is a very important acronym in your life. You should remember this fact. So first attempt. So you may wonder, so I'm a good student up to +2. No, why this first attempt? Because the engineering engineering curriculum and engineering method of examinations patterns are different from conventional school education. Therefore, here first attempt is very essential, because many of the recruiting company, they will be look for first attempt, and also you should score high marks. Okay, and also foreign language and good attitude, communication skill, positive thinking, and talent exhibition. With this, I think you can be able to success in the engineering industry market. Thank you. Thank you.
Thank you, sir. Thank you for your very insightful presentation. Actually, like, I mean, we are running little late, and our last speaker, Dr. Shankar Subaratnam, he has some other meeting at 1 o'clock, so he just wants to swap his session with Dr. Ganesh, and I thank Professor Ganesh. He has kindly agreed to the request. So I now request our next speaker, Mr. Sankar Subrathinam, to present his point of view. To introduce Dr. Shankar, he is an engineering manager at Caterpillar India Private Limited, Chennai. He is a graduate in meteorology from GCE Salem, University of Madras, and MS by Research in Meteorology and Materials Engineering from IIT Madras. He has completed MBA in Operations Management, and he is also a certified Six Sigma and Caterpillar Production System Black Belt from Caterpillar University, USA. He has about 27 years of experience in automotive industry, having worked in OEMs, Ashok Leyland, Tafe, and Tier 1 auto component industries like Born-Warner, Rane Engineering Walls, predominantly in the quality assurance, product engineering functions, and metallurgy lab. He has also headed the corporate quality assurance functions in several companies. He has got memberships and presidentships from several professional associations. So, like, I mean, the list is huge, but since he has some meeting at 1 o'clock, without wasting any time, I'm handing over the mic to Dr. Shankar. Sir, please.
Okay, thank you, Dr. Muthamil, and I'm happy to share my presentation with the students. Are you able to see the screen?
Yes, sir.
Okay, so I've been listening to the other presentations, and more or less whatever I've been trying to tell our friends has been covered. So my job is actually made easy. But just to share some of my thought with the student community, so I would like to tell by starting that these are changing times. So in fact, I made this presentation when things were good, probably about 2 years ago. And these changing times, I do not refer to the current situation. So the changing times I refer to here, the disruptive technologies and the rapid changing of technology and things. So this graph actually shows that if our thinking is going to be linear, then the world is going in an exponential direction. So we will have a huge gap. So you are thinking that you will be reaching here, starting here, but actually the world is going in this direction. So if we are not prepared, we will end up with a huge gap. So having said that, so one example that I can tell you is the technology and the developments are changing so rapid that probably what you study in during the first year may not be relevant, and the new technology would have replaced it when you have already come to final year. So this is the kind of rapid changes that are actually taking place. So to quickly capture what my thoughts are about the future prospects for the budding mechanical or automobile engineering or manufacturing engineering is that, as one of the professors mentioned, simulation is going to be a very key thing for the probably at least the next 5 years, I can say. In fact, the Caterpillar adopted this enterprise simulation strategy as one of the key area of focus, and we have implemented a lot of these kind of simulation things in our regular day-to-day work. So some examples I have given in this slide. So these are areas where I think there will be some more kind of developments, and future prospects will be bright. So where, for example, you have this crash test, which companies these days, they want to also cut down on time as well as money. For example, if you take the case of Maruti, who is a car maker, he will release about 4 to 5 models in a year. So that is the kind of speed with which the companies are working. Imagine releasing 5 different models within 1 year. So how are they able to do this? Because in olden days, everything will have to be physical test. They will make a proto sample, then they will make these kind of samples to undergo test. This will go for road test. So for releasing one model, it used to take at least 1 year, 1.5 years time. But things have changed, and you all can see companies like Maruti or Hyundai or any other new company that has come to India like MG. They release minimum 4 to 5 models every year. How is it possible? Because they are cutting down on the testing cost and time. And here is where the simulation has come into picture. Professors also explained about virtual reality immersion, where they are extensively used in new product introduction. I hope my colleague and friend Dr. Bala will be talking about FEA and CFD and things like that. And as far as manufacturing engineering is concerned, people are more tending towards this kind of simulation software. Some examples that I have given: Magma is used for casting simulation, Deform for forging simulation, things like that. And now that we are moving from BS4 to BS6 and all that, a lot of requirement will be in terms of fuel economy, noise, vibration, harshness is a very, very big emerging field where we do not have adequate expertise and field. Battery, anyway, people are talking about electric vehicles and things like that. So these are going to be the huge areas where people, if they have some interest and if they put some focus, there's a lot of scope for them. Again, people also talked about Industry 4.0. So Industry 4.0, if you have to give a very, very concise and precise definition, you can say that industries are moving towards real-time data collection, because that is how not only it is remote, but also it is real-time. Real-time in the sense, probably you have to collect data every second, and it doesn't end there. The data is collected, analyzed, and this data is interpreted. And a lot of these statistical process control techniques are used, and this data is actually used for process improvement. So it is actually a full circle, full cycle. So this is what is generally referred to as Industry 4.0. And you have digitization everywhere. You have earlier, those days, maybe some 10 years back, you go to a shop floor, people will be talking about breakdown maintenance. So from breakdown maintenance, people came to preventive maintenance, and then a first step further, people have already gone to predictive maintenance. That means what? There will be zero breakdowns, or there is zero lost time due to machine breakdown and things like that. Machines are now getting connected. You have connected machines, connected cars, even the mining trucks that we are making in Caterpillar, they are used in very harsh conditions, the mines. Even there, we are having a lot of remote monitoring of these trucks and machines. A lot of scope is going to be in PLC and CNC programming. And there is also going to be heavy demand for people who are very good in Lean and Six Sigma tools, statistical tools, because these are core crux things for this Industry 4.0 for process improvement. And this is also in line with Digital India, what the government and the Prime Minister and various government departments are actually encouraging people to go for this. Okay, so I told so many things. I told about the simulations and things like that. So you may ask a question: are you telling the truth? How can I believe? So you can see, as many of the previous speakers also mentioned, the engineering curriculum is becoming more of interdisciplinary, in the sense that mechanical engineer is required to know a little bit of electronics, little bit of electrical engineering, little bit of computer science, coding, programming, and things like that. So that is actually getting reflected in, this is a manufacturing engineering where there is a seminar which is going to be on sheet metal forming application, which is actually a metallurgical process where simulation is used. So this demands knowledge about metal forming as well as familiarity with the softwares. Okay, and with respect to jobs, so I am just giving an example of a probably a smaller industry where they are calling for engineers who are experienced in simulations. Okay, so imagine smaller companies are asking for people who have expertise in simulation. That means the bigger companies already have embraced or started in a wider way. So these are some examples which I took, and this is one another example which I would like to show, where a company which is designing helmet. Their helmet, how much would you pay for a helmet who is probably about the 500 rupees or 1000 rupees. But even for such a lower cost product, people are using simulation techniques. So people are using this to calculate how much a person will encounter in terms of force if he is without falling from a two-wheeler or something without wearing a helmet, and how the helmet will protect. So the head acceleration is calculated, and see without a helmet how much of acceleration your head will experience and how much of force the skull will experience, and with helmet how much it is getting reduced and how the person's head is saved. So even for a product such as the helmet, people have gone for using of simulation software. So this is what I am trying to tell you. So one another tip that I would like to give to our budding friends is that you should be aware of the kind of jobs that are available in the market. So there are two approaches. One is a top-down approach and another is a bottom-up approach. So if you see that, first of all, you should have some kind of you should develop some kind of a liking. Okay. So by attending seminars like this, you are exposed to a lot of topics, lot of subjects, lot of titles, and this makes you, I mean, at least one or two topics from this will interest you. And you have to select that and then go a little deeper into that. And you have to find out what are the skills required and where you are and what is the requirement. There is a gap. So you have to develop and enhance these skills. So if you're able to do this, I mean, it is a very, very simple thing. All that you have to have is a smartphone with the internet connection. The companies that you like, you can go to their career sections and look for the kind of jobs that are getting advertised. You look at the JD, and you have to match your skills with the kind of jobs that you like. Then you have to bridge the gap. Then you are much more employable in the market. So again, some more tools which I have discussed previously. One more thing that I wanted to tell you is, as mechanical engineers, it is also important to know something about materials, because if a mechanical engineer wants to pursue a design career, the knowledge of materials is very, very important. And without that, it is very difficult. And again, one more emerging field is the integrated computational materials engineering, where you can have the materials by design. So this is like something like a tailor-made material. So you have process on one hand, you have various materials on the other hand, and then you can mix and match, and actually you can design a material for a very, very specific requirement. So this is one of the most fastly emerging field that I can say, ICME, and the people who are interested, studying mechanical engineering, but who are interested in knowing something about materials, their properties, can focus in this area. Okay, so I made a comment in the beginning that things are changing so fast, and probably one technology that you are studying in first year may not be there in the final year. And it is also not possible for the universities and colleges to have experts and professors in all the emerging technologies. So you are, I mean, on one hand, the technology is changing. The other hand, there are not many experts available in this field. So how you can educate yourself, how you can learn. So there are a lot of online tools available. So these most of this, like NPTEL, is for free. You can listen to some of the experts, and the best thing about this is these are very, very flexible, and it can suit. You can study as per your wish. You study today morning, and tomorrow you can study in the night. You don't study for 1 week, take rest, and then start again. All this kind of flexibility is available in the kind of online tools that you have. And now these are the ways where you can keep abreast of the technology, the latest things in technology, even if you or college or the university is not able to have an expert in a field that you like. So there are other learning opportunities like internships, which the professors mentioned. And I also strongly recommend the students to be part of some professional societies like SAE, where you can participate in events like BAHA, and you can also become professional members of ASM International and things like that. So they offer not only learning opportunity, but also the power of networking, where you will get to know people from different industries, different companies. You will know about the job vacancies. Many people are ready to help you by providing internships, by giving information about the job opportunity available in some other company, things like that. And as Professor mentioned, it is also good to do some mini projects. Even if you fail in that, it doesn't matter. But what is more important is that you worked on a project hands-on and you learned something. So that is much more important. So I think I have come to the end of my presentation. So I wish everyone all the best and good luck. Thank you.
Thank you, sir. Thank you for showing the students the ways and strategies in building their career. So with this, now I invite Professor D. Ganesh from Department of Mechanical Engineering, CEG, Anna University, Chennai, to deliver the next talk. He joined the university as a lecturer in the year 2003, and he is serving there for the past 15 years. And he is involved in teaching and research in the fields of IC engines combustion, emission control, and the alternate fuels and powertrain. He completed his diploma in mechanical engineering in the year 1997, Bachelor of Mechanical Engineering in 2000, Master of Mechanical Engineering or Master of Engineering in Internal Combustion in 2001, and PhD in Mechanical Engineering in 2011. After completing his PhD, he did his postdoctoral fellowship under the sponsorship of Raman Indo-US Postdoctoral Fellowship awarded by UGC New Delhi. He did his postdoctoral fellowship at Engine Research Center, ERC, University of Wisconsin, Madison, USA. Now it is over to Professor D. Ganesh.
Thank you, sir. Thank you for the introduction. And so very good afternoon to all. So I'm going to present my topic on automobile engineering challenges and opportunities. So my content of presentation will be, I'm going to discuss about what is all about automobile engineering and what are the basic skill set required to pursue automobile engineering, and then what the presence of automotive industry in India, and the challenges that are existing in automotive industries and the technologies that are developed as a result of the imposed challenges, and then what is expected from the future automotive engineers to take a role in automotive industry, and then what are the higher education opportunities in India as well as in abroad, and finally the additional qualifications that are required to seek a role in automotive industry. The automotive industry is the one which is changing every day as new technology arrives, and therefore one who wish to take up the mechanical engineering, or one wish to study mechanical engineering and automobile engineering has to keep themselves updated with the current affairs in order to pursue a career in automotive industry. So that is why I mentioned here that automotive industry is one of the key adopters of advanced technologies, and which is resulting in rapid innovations and disruptions in this sector. So for the young body engineers, whoever is passion towards automobile engineering, so they have to mold themselves with the required skills to seek a role in automotive engineering. Let's see what is automobile engineering. It is basically it's derived from the mechanical engineering. It deals with the design, development, manufacturing, production, testing and repairing, control and management of automobiles. It is also the combination of different elements of mechanical engineering, electrical engineering, electronic engineering, software engineering, and safety engineering. It is almost like an interdisciplinary engineering subject. And major tasks of an automobile engineer are to design, develop, manufacture, and test vehicles from the conceptual phase to the production phase. So it has many areas of specialization such as engine systems, fluid mechanics, aerodynamics, supply chain management, thermodynamics, and electronics and control systems. So in automobile, an internal combustion engine is the heart of the system. So it is very important to understand how internal combustion engines functions, how the mechanisms of the vehicle chassis, and the electrical systems and workshop technology. And also you should know about the motor transport affairs and research and design. All these things are very important, and those things you can learn in this particular part of engineering, that is automobile engineering. So the required skill set for automobile engineering are basically the student must have the interest in science, because the physics, mathematics, and chemistry, these are the subject is going to play an important role in understanding the subjects in the engineering course. So they should have basically interest in the science, and also they should have interest in cars and auto mechanics, and also they should have a knack of working in organized and systematic environments with the skill of time management, because automotive industry is highly competitive environment. They have to be very competitive with the other manufacturers, so they have to deliver the products in time. So you should have a time management skills also. Then the student should also have an interest in resolving mechanical problems, and also they should have a keen sense of creative and innovative solutions in repairs, designing, and drawing are the potential candidates for this type of degree course. So next, this slide shows the current status of the Indian automotive industry. I hope and everybody is aware that Chennai is nicknamed as the Detroit of India. We have many automotive industries in and around Chennai, and not only automotive industries, the tire manufacturers and auto component manufacturers. So automobile industry in India is one of the emerging sector, and which is contributing to the Indian economy, both in terms of the revenue as well as the employment. And also this sector is one of the major sector which is recruiting more than 10 million people in the country. And this sector basically is a comprises of heavy vehicle industry and passenger vehicles and two-wheelers and three-wheelers. So you have a lot of opportunities to get into these companies, and if you have a proper skills. So what are the challenges in the automotive industry? The first one is the environmental impact, because the automotive industry is under constant pressure from the environmentalists as well as from the customer demands, because the climate change issues that has arrived because of the greenhouse gas effects due to the gases like carbon dioxide, sulfur dioxides, and oxides of nitrogen that are coming out from the engines, which is creating a lot of problems in the environment. And also the emission species like hydrocarbon and carbon monoxide and particulates that are also affecting the human health. So this leads to the increasing regulations on the vehicles. So the government has enforced a very stringent emission regulations. Though currently the government is also decided to shift from BS4 to BS6, bypassing the BS5 norms. And here the BS stands for Bharat Stage emission norms, and which describes the limits to the engine out emission spaces, so that the every manufacturers and they have to meet these norms in order to reach the market. Then another important challenge enforced by the government is also the fuel economy, because the carbon dioxide emissions, if you want to cut down the carbon dioxide emissions, your vehicles should have a highly fuel efficient technology. So in this case, the materials plays a vital role in terms of the fuel economy, because the material selection plays a vital role. We need a very lightweight materials for fabricating the vehicle. So because of the R&D, you can see that almost more than 200 grades of steel so far is developed for applications in use in the vehicles. And also the composite research is also helped in choosing a right and lightweight material for the automobile application, that is really helping to cut down the carbon dioxide emissions. And in order to even to target the CO2 emissions, the industry is also trying to bring in the hybrid electric vehicles and electric vehicles. And hybrid electric vehicle is the combination of the ICE, that is internal combustion engines, and the electric, whereas the electric vehicles is the purely driven by the motors and batteries and other systems. Then one more challenge is nowadays the consumer demands is also changing from ownership centric to the service centric demand. So the manufacturers, they also devise a different strategy, and in order to increase their sales, to considering all these effects, and also the rise of globalization, then rising market competition and maintaining cost. So whatever you technology you develop in order to meet the regulations, so the cost of the vehicle should be within the bias capacity. Then only you can compete with the other competitors. So the maintaining cost is also very, very important. That means so our solution should be a very cost-effective solutions. And India is mainly seeks to bring emission standards in line with the global standards, because previously we are just way behind the Euro norms. Now the government has decided to match with the global standards. So you can see here the picture, the CO2 emission targets that are to be met in the current scenario as well as in the future scenario. So currently, that is the world of today, which has to meet 100 gram per kilometer of CO2 with the help of the ICEs and mild hybrids options. Whereas if you go beyond that, and so the CO2 targets are very stringent, we have to below 100 gram per kilometer CO2 target, as well as 50 gram per kilometer CO2 target in the futures. So those can be met with the help of the electrics and the plug-in hybrid vehicles, and also with the help of employing the high efficient combustion technologies and after treatments, and we can also meet the future CO2 targets. So this shows the technologies evolved because of the very stringent emission norms. You can see today, because of the hard work by the industry in the past 3 years, they are able to push all their powertrain to qualify the BS6 emission norms with the effective after treatment technologies. So already the internal combustion engines, which is having advanced technologies like very flexible high pressure fuel injection systems and turbochargers, VVT, that is variable valve timing, and then multi-valving, and then exhaust gas technologies. In addition to that, we are going to also have the after treatment technologies in order to meet the emission norms, particularly the NOx and particulates and hydrocarbons. We are going to see all these after treatment devices like diesel oxidation catalyst and diesel particulate filters and selective catalytic reduction and also the other slip catalyst. So you are going to see a lot of technologies enabled in the vehicle in order to meet the emission norms. So all these technologies are raised mainly because of the challenges. So automobile industry is always have challenges. So you have a lot of scope and opportunity to do a lot of R&D. So when there is a scope for R&D, there will be a scope for the job opportunities. This shows the example, the exhaust layout for the BS6 vehicles, and you will see all the after treatments in the exhaust, so that so whatever comes out from the engine, which can be treated, all the emissions can be treated with the help of this after treatment devices, so that the gases which is expelled to the atmosphere will meet the norms which is prescribed in the BS6. Then alternate to IC engines, the industry is bringing in electric vehicles, but the electric vehicles having its own challenges like energy and power density and battery charging and lifetime performance and system cost. Because today with the IC powered vehicles, we can travel more than 300 miles and also we can fill up very fast. Whereas with the electric vehicles, with the available energy and power density, it's very difficult. And also the charging infrastructure, as of today with the available data, we have only 600 charging stations across the country. So charging infrastructure and electricity requirement and the lifetime performance of the EVs is not able to match with the current ICE performance. So a lot of challenges are there even in the electric vehicles. So the upcoming engineers who is pursuing engineering in mechanical and automobile will have a lot of scope to work in this fields to deliver solutions. So this slides actually I'm going to share from the recent interview given by Mr. R. Velaswamy, the Senior Vice President of Mahindra and Mahindra with Autocar India. He has clearly explained and what is expected from the future automotive engineers. So he said in the present day, the innovation is all about the interplay of various engineering disciplines in not just one form of education. So now the time has come to move from interdisciplinary innovation to interdisciplinary innovation, because the automobile is a mixture of mechanical engineering and chemical engineering, and then electronics and electrical and safety engineering, many things. It is a complete mixture of different disciplines. So the engineers, whoever is pursuing mechanical and automobile engineering, also be updated in other disciplines like electronics and electricals, and also the little bit of chemical engineering, also a little bit knowledge on electrochemical engineering is also required in today's environment to cope up with the rapid change in innovations. Then the concept of physics and materials and mathematics will continue to form a base knowledge. With this base knowledge, you should pursue additional qualifications to seek a role in the present scenario. And also he said today there is a blur and fusion in various engineering disciplines. Also one needs to follow their passion and work in teams to produce innovations. That is more important in today's scenario. And also he said more than technical skills, it is cognitive and social skills that are important in an engineering environment and are the prerequisite that is stressed upon by the automotive industry from the candidates to seek a role in the automotive industry. And also he said most people are thinking that when the hybrid and electric vehicle technology pitch into the automobiles, the mechanical and the other engineers will lose their job. It's not like that. And these two technologies also an amalgamation of mechanical and digital and electronics. And these are the new forms of understanding that one must really should acquire, so that you can develop your skills in other disciplines also in parallelly while studying mechanical and automobile engineering, so that you can mold yourself to fit into the future upcoming challenges. And you should have an integrity, honesty, and the ability to work within the teams. That is also the additional qualities expected from the candidate to take a role in automotive industries. And also students, especially the coming engineers. And this generation is very strong in coding and developing app because in automotive, the technologies like autonomous technologies and connected cars technologies and need a lot of complex coding in order to understand the present traffic conditions and driving without any manual input on the cars. So these technologies need a lot of inputs. So the young students must seek a role in R&D, that is the research and development, and particularly those are very much interested in applying fundamentals of science to solve the customer problems and delivering required products. And suppose if anybody is interested in marketing and sales, you can even do an MBA after engineering, so that accordingly you can take up a leadership role and focus on that area in the automotive industry. And also, Mr. Velusamy said, and people, cognitive and imaginative skills will be the enablers to one's success in the industry, because you need to have a very intellectual and imaginative skills that should address the social problems, so that so your solutions will be very cost effective, and that will be a key success for the industry. And also he said machine learning and deep learning will be the differentiating technologies of the future. So the engineers, the participants, whoever is watching this webinar, also you should develop your skills in machine learning and deep learning, that is particularly in artificial intelligence and phonologic and generic algorithms. In those areas also, you please concentrate and develop your skills, and that will be very useful for the automotive industry. Then rapidly increasing cognitive and logical power of the chips, which is basically redefining the automobiles and turning them intelligent devices. Those will be help to talk to their the users in real time. So nowadays, because of this advancement, the vehicle will have a very good communication in both the ways. So if you want to develop such vehicles with a very good communications, so you need to have very good learning in all those the areas which is addressed in the previous slides. So he said EVs definitely will take over, but how fast, it is still questionable because of this pandemic situations. And so 85% of the vehicle volumes still is going to be occupied by the internal combustion engines. So the internal combustion engines also can meet the enforced CO2 targets by developing new or enabling a new combustion, high efficiency clean combustion technologies with help of mild after treatment technologies. It is possible to meet CO2 targets. So the mechanical engineers and automobile engineers can also focus on the internal combustion engines, particularly on the combustion, how to improve the combustion of the fuels and the different liquid fuels that are available in the country. So if you're able to develop a very high efficient combustion technology, which can consume less fuel and have the same power, so that will be very useful to meet the CO2 norms. So next is the higher studies opportunities. I have listed the few the institutions, the national level as well as the international level. After completing your BE and BTech programs in mechanical engineering and automobile engineering, you can take up the Master of Engineering, that is MBA and MTech programs, also the MS programs. For pursuing MBA and MTech programs in the premier institution, the national level, you should appear for the GATE exams. You should clear the GATE exams. So once you clear the GATE exams, according to a score, that is a percentile, so you will get the admission in the premier institutions. So you can join and you can enhance your skills about, because when you go very specialized in your master program, so you will get a very specialized knowledge in the focused area. So that will be more help to seek employment in your passionate area. And also, while studying engineering, you can participate in the workshop that is organized by the IITs and IIC and Anna universities and national universities and National Institute of Technologies, so that you can time to time you can update your skills, and you will come to know what is happening in the current scenario, particularly in the automotive industries, because the workshops will be organized towards the current scenarios, that is emerging trends. So you will be updated. That will be very useful in seek a career in automotive industries. Suppose you are interested to go for an higher study, that is MS program in foreign universities, particularly in automotive engineering, you can choose some of these universities. In this, and particularly, I want to say about the IFP, the France, the best school for the automotive studies. And after completing your BE, and if you apply for this school, and once you get selected in the screening process of the IFP, and you will be connected to two industries, then the industries will organize a technical interview with you. And if you got selected, then that industry will sponsor you for your MS program. So with a $0 fee, and you can complete your MS program. But only thing is, after completing the MS program in the IFA school, and you have to work in the sponsored company for a particular period of time. So based on your contract. So it's a very good scope for the engineers. So whoever is interested to pursue automotive engineering, and you can also study the automotive engineering in all these universities. And as an additional qualifications, and you can also learn these tools. Here I want to stress upon that the mere tool knowledge will not help you to seek a career in any industry. So you should have a very good fundamental knowledge. Along with the fundamental knowledge, if you're able to learn these tools, then you can very easily apply to the need of the problem. Then you can deliver an effective solution to the problems. So learn all these tools, the Python, MATLAB, and Simulink. Scilab is open for ANSYS and CF, Star CCM Plus, and Star CD, and DOS CFD, DOS Basic, and expert solution for IC, that is internal combustion engine, Converge, and AVL Fire. GT Power is one of the widely used. AVL Fire and GT Power is the tools that are widely used in industries. And QA is one of the chemical kinetics tool mainly used for optimizing the combustion process. And if you learn all these tools in addition to your engineering skills, and definitely you will get a job in the automotive industries. And one more thing I would like to share here is the ARAI, that is Automotive Research Association of India, is conducting time to time a lot of proficiency improvement program on engine calibration, controls, and also EVs and other technologies. So you can take part in those proficiency improvement program. You can get the certifications. All this will added up as an extracurricular activity, so that you will, when you apply for a job, all this will be seen as emerging qualities from the candidate, so that you can get a job in automotive industry. So with this, I'll complete my presentation, and thank you for listening, and also I'm ready to answer your questions at the end of the session. Thank you very much.
Thank you, sir. Thank you for showing the opportunities and challenges that exist for the aspirants in this field. So our next speaker is Professor Samuel Raj from Central Workshop Division of Department of Mechanical Engineering, CEG, Anna University, Chennai. He pursued his BE in Production Engineering from MIT and ME in Manufacturing Engineering from IIT Madras. He has received his PhD in Drilling of Composites from Anna University. He began his career as graduate engineering trainee at Tata Motors, and he served as a lecturer in RMK Engineering College, Chennai, before joining Anna University as assistant professor in the year 2010. Dr. Samuel Raj has expertise in quality control, lean manufacturing, and machining of FRP. And today he is going to talk about mechanical engineering, what's next. I welcome Dr. Samuel Raj to deliver his talk.
Thank you so much. Yeah, so we'll move on to the topic, which is mechanical engineering, what's next. So a lot of the lectures, what you're hearing over the past 1.5 to 2 hours, have given to you maybe a comprehensive overview of what you might see in mechanical engineering. So specifically, and we had another 2 lectures which talked about manufacturing field and then the automotive sector. And we also had an industry expert who told you the importance of learning things apart from more what is being taught in your curriculum, so that you are prepared when you get into the automotive sector or into the industry. So what I am going to share for the next few minutes is what are the opportunities available for mechanical engineering? Even though my title says mechanical engineering, what's next? Uh, the points I'm going to discuss right now will be equally applicable for people from any engineering background, except for places where it specifically deals with mechanical engineering. So this might be applicable for every engineering graduate as such, right? So we have an audience which is a mixture of both students who are in their school who are going to enter engineering, and we also have students who are already in their engineering career course. So the importance of the undergraduate study, that's the engineering course which you are studying right now or which you're going to study, cannot be understated. It's very important because it lays a foundation for your career. Now, many people would have told you in your school as school students, like the school serves as your foundation. Yes, that's true. And you might have maybe come out school with an assumption or with a wrong notion, saying that, okay, all my fundamentals are complete, and what I'm going to do in my college is just the application. No, it's not like that. Your fundamentals continue even in your college, and the foundation for your career, even though it's laid in school, is continued even here in your undergraduate curriculum mainly. Maybe your postgraduate is mainly application oriented, but your undergraduate serves as one more foundation, or helps to strengthen the foundation which you already laid in your school days. Now, very often what we find as teachers is people who have done very well in their school days, people who've scored extremely high marks, people who got centums in more than one subject. When they come to college, we find that they are finding it difficult to replicate their success in terms of marks, in terms of the jobs they get when they move out of college. We find, in fact, we've seen a few examples of students who even failed to complete their course. People who scored very high, they failed to complete their engineering course after joining in a very good engineering college like even Anna University. Many cases, the problem lies with some of the fundamental ideas which we have in our mind. Since our school days, right from our teachers, our parents, even ourselves as students, we think that getting an admission into a good college is the goal or is the destiny, and that completes the purpose of our life. And we assume that once we get into a good college, everything is completed, and we're going to our safe career is assured. But that's not always the case, and that's one of the major mistakes which people do. And this is a problem even with which is facing students who get into IITs, because you know that the JEE entrance exam is one of the hardest to crack. And the moment students crack the JEE exam, when they go to the IIT system, people no more have the motivation to study there, because they feel that they've reached the pinnacle of their career in terms of cracking the JEE, and there's nothing more to establish or accomplish in their life. That's a wrong way of looking at your undergraduate education. The next thing which you'll have to be careful about is, during your undergraduate curriculum you will study, you know that people who are already in your engineering, you will not be monitored as closely as you were in your school days. You had in your school, you had your teachers, you had your parents closely monitoring you, what you were doing day in and day out. But here in a college, you will be treated as an adult. So it's your responsibility to take care of your job. There's nobody going to come and tell you, do this, do that. So you will have to, as maybe a 17 or an 18-year-old person, you will have to learn to start living life independently once you come into college. The next thing which we very often find as teachers, very often we find it difficult, is a large section of the students, we find it difficult to motivate them. We often have to force them into, whether it's a classroom discussion or a project or doing some kind of a co-curricular activity. We have to often force students to do that. Force in the sense, compel students to come and participate. And the sense of students who are very active in their school days and doing a lot of extra things apart from their studies, they start losing their interest in other activities when they enter into college. That's one very wrong thing which students do, because these are things which will actually help you in getting into a good job when you sit for your campus interviews at the end of your 4th year. The next thing is, many students often wrongly assume or perceive that there's a disconnect between what you learn in your class and what you need when you go to say a job or in terms of a career. Many students wrongly assume, maybe out of wrong advice, that what is taught in class is not important. We are not going to use that in our job. That's a wrong kind of notion which many students have. In fact, we come across many students who tell us, when we ask them as to why they are not showing interest in their classes or in academic activities, this is the answer we get from a lot of students. What do I do by learning this? My job is not going to require any of the knowledge I learned here out of the 4 years in an undergraduate education. Now, this is another wrong notion which people have. You have to understand that what you study here as maybe what we call as theory, or in your classes here in your undergraduate education, that along with your practical skills, again, what you acquire in terms of the laboratories, the projects, the internships, in-plant training, etc. Together, that forms the learning experience. So it's that learning experience which is important when you get out of college. It's not when you sit here, the wrong notion that what I study here is not going to be useful in my career or in my job. That's the wrong notion which people have to leave, or which people have to forget when you get into a classroom, because unless you forget about this, you will not start learning when you go to a classroom. When you get into your undergraduate curriculum or study, especially for people who are in your first or second year, or people who are yet to get into your undergraduate study, you have to realize that what is taught in the classrooms for 4 years is one aspect of your knowledge. You will have to supplement that by a lot of other activities. A lot of speakers before me talked about the importance of in-plant trainings or internships, etc. You have a lot of opportunities for internships coming from both industries and as well as academic institutions. Specifically, the IITs, which are one of the premier institutions in India, they offer internship to students when they are in the second year and some third year during the summer vacation. So you can keep looking for internship opportunities in IITs. Keep looking at their websites during your second year and third year. You will have to apply, and if you're selected, you will be given the opportunity to intern under a professor for a month or for more than a month, and you learn a tremendous amount of information by working under such learned professors, because the kind of facilities which IITs have are second to none in the world. So you can really supplement what you've learned here in your undergraduate curriculum by such internship opportunities carried out either in IITs or even in industries. You can approach industries. Certain institutions, at least like the premier institutions like Anna University, allows for internship, or companies visit the university to offer internships to students. So if you supplement your curriculum with such internship opportunities, then you're placing yourself in a better position in your career when you move on to an employment or for further higher studies. So but you can also look at carrying out projects during your 8th semester in an industry itself, instead of carrying it out in the college where you're studying, because that again will give you a slightly better exposure about what an industry expects when you get out of college. And the other thing which you have to realize or give importance to is the co-curricular and extracurricular activities as part of your college days. Now, you can maybe remember it's 4 long years, so you'll have to start looking at sports, arts, or things which you were doing in your school days. We have a lot of facilities at every college, or every institution has a lot of such societies for sports and arts, etc. We have a lot of technical societies, but many times we find people who are really good in sports and arts not continuing their passion when they come to the undergraduate education. Similarly, you'll have a lot of technical societies within your department, and these societies also require good amount of participation from you. So you need to actively participate in such societies, because it is these extras which will actually help you to show that you are better prepared than the next person or the next student. So it is all these things which will supplement what you study in your 4 years of classes. Now, once you finish your 4 years of undergraduate education, the question which comes is, what are the opportunities available in front of me? Now, I've listed some 4 opportunities which are available in front of the four common opportunities which people look at. The first thing is employment after you finish your undergraduate education, directly get into a job. The second thing you can do is you get into a higher studies. I want to learn more, either from the management side or from your engineering related curriculum. Or you can start your own business, you can become an entrepreneur, or you can follow your passion. Maybe your passion might be in arts, your passion might be in photography, you might be a sports person who would like to excel in the sports, chosen sports field. So that's up to you. So you can choose one of these and you can excel in your career. We'll start, go one by one. We'll look at employment as a career. Now, there are a lot of opportunities for mechanical engineers. Some of the fields were listed by Professor SHANMUGA Sundaram when he gave the first lecture. I've just maybe listed them here, so this might be a little superfluous. So I'm not getting to each industry because these have been covered in very great depth by the earlier speakers. So these are the opportunity or areas where a mechanical engineer can get into. So if you're an engineer from some other field or you're getting into some other branch of engineering, then accordingly, depending on the branch where you're getting into, you might have your own field. So for a mechanical engineer, the fields which are commonly available are automobile manufacturing, engineering services, thermal power plants, etc. Now, people who are sitting for your or who are already in your engineering course, or people who are coming into your engineering course, remember, there's a process called as campus recruitment, which happens at the end of your fourth year or at the end of your third year, to be more correct. So during the beginning of the fourth year. So where the company comes to your campus to recruit you, and this is a process which is generally followed. So it's usually a 4-step process, and you might have one more extra step, or one of these steps may or may not be there depending on the company for which you're applying. So usually, remember, we are talking about a lot of students in your department, in your college might apply for the same company. So the easy way out for companies is to filter you out based on the marks you've scored up to the third year. That is up to the 6th semester. So scoring, getting good marks is very important. So it's not only the knowledge which you acquire in your class, that has to be replicated in terms of marks, because a company will know your knowledge only when you first go to you're able to get through the first stage. If you say that I have good knowledge, but that does not get reflected in terms of marks, then you will not get an opportunity to go and speak to the people in a company. Yes, there are exceptions, but otherwise, the general rule is you need to have scored well in order to first clear the first stage. That is, getting into the second, getting shortlisted for the test. So that's the first stage. So you need different companies, depending on their requirement, will have different levels of cutoff. So depending on the cutoff, you will be selected for a test. And the test will usually have a technical, will test your technical knowledge, your aptitude, that's your problem solving skills, etc., and your English language usually. And then if you get selected through the test, you go for a group discussion. And in a group discussion, it's very important that you are knowledgeable about what is going on in the outside world, for which you'll have to read a lot of newspapers. Listening to news channels is maybe one way, but today's news channels are not really informative. So it's better if you read good newspapers like, say, the Hindu, where you will get a lot of useful information, which will really help you when you sit for a group discussion or in a personal interview. So last stage is in your personal interview. This is where you get the chance to impress the person or the interviewer sitting in front of you as to why you are the person who's meant for the job. So you'll have to show him, or you'll have to tell him that I am the one who's looking, I'm the right person whom you're looking for. Give me a job because I have all these skill sets. So it is here that all the skill sets which the earlier speakers talked about will really help you. Apart from your curriculum, because during the interview, you'll also be tested on your knowledge. A part of your knowledge is going to be tested, your technical skills, what you've learned in your 3 years. But remember, the other half of your interview will deal with your projects, what you've done, your co-curricular activity. So it is here that your participation in your technical societies, your participation in paper presentations, your participation in internships, in-plant trainings, all of these will really help you. As well as the project is again one place where a lot of students wrongly assume that it's just look at it only in terms of the number of credits which you have to earn. Project is something which can really help you get a good job, because project is one place where you apply what you have learned. Because during the 3 years, what you've learned in your undergraduate, the first 3 years, what you've learned, you start applying them in your 4th year when you start doing your project. So people talked about simulation, finite element analysis. A couple of speakers talked about that. One place where you can apply all these concepts of finite element analysis, what you learn in your undergraduate curriculum, is in your project. So it is here that you select a suitable project where you will be able to apply these simulation concepts. And when you sit for an interview, if you've done a project where you've used these simulation concepts in your project, now that will make you a better employable person. And one more important thing to make you a better, more employable is to get additional certifications. The earlier speaker talked about certifications like NPTEL, etc. So IITs conduct a lot of online courses which you for which you can give exams, and if you clear the exams, you get certificates. So the NPTEL certificates are important. You can get certificate courses from other leading organizations like ASME. You have societies like, say, the non-destructive examination for which you have society. So Indian Society for Non-Destructive Testing, they conduct a lot of exams to certify you as a certified non-destructive tester. So a lot of such courses are available, and it's better if you get yourself certified by such certification agencies, because this will help you to gain an edge over the next person or your neighbor. So as an employment opportunity, a lot of opportunities are available in the government sector. So civil services, most of you might know. Some of you might have an aspiration to become an IAS or IPS or IFS officer, for which you'll have to sit for the civil services exams after your engineering course. You also have the engineering services exams called as IES, which is specifically meant for the engineering graduate. So civil services, any graduate can apply for a civil services exam, but for an engineering services exam, it's only the engineering graduates can apply. So a lot of interesting job opportunities are available in the engineering services sector, in the power plant sector, in the railways, in the army. So you can get into really technical jobs when you clear the engineering services exam. So you get selected as say an assistant engineer, and by your 20th year, after 20 years or so, you will reach the level of somewhere close to an additional say a general manager, some kind of, say, leading a very big public sector industry like a power sector organization. So engineering services is again a very say a lucrative as well as challenging job for engineering graduates. Many students don't do that. Now, the important requirement for an engineering services exam is you be very good in your fundamentals, because questions are asked from subjects which you learn right from your second semester, including your mathematics. So you need to be really good in all the subjects which you study right from your second semester onward. So if you are a school student who's about to get into an engineering course, remember, right from your second semester or even from your first semester itself, you need to study every subject with the utmost importance if you have any intention of cracking such exams like the IES. Then you have the banking sector, where you can get into as a probationary officer. People who are interested in finance, at the end of your 4th year, you can also sit for a banking sector exam. A lot of public sector banks conduct exams, so you can clear the exam and you can become a probationary officer. So that's one interesting opportunity. The armed forces give you a very good opportunity to serve the nation. So there are two options here. One, you can either become a permanent, enter into as a armed forces as a permanent commissioned officer, or as a through short service commission. A permanent commission is for a career in the army, for which you'll have to write the combined defense services examination after your graduation. You can look at the Indian Army website, which gives you a lot of information about the CDS examination. And then there's the other opportunity for short service commission, where you get into the army for a brief period of, say, 10 plus 4 years. And if you are willing, you can continue in the armed forces as a permanent career. Or if you're not willing, after your 10 plus 4 years in the army, you can come out. And remember, the army teaches you lot of important administrative, technical, and managerial skills, so which you can never learn from any private sector industry. So the armed forces give you a very good opportunity to learn or to know more about you. So at the end of, when you join the army as a short service commission officer, after 10 plus 4 years, you have the opportunity of coming out or continuing. And if you come out, a lot of industries are willing to take you for very good jobs. Remember, the army teaches you a lot of important life skills. So again, that is based on your marks. So recently, the 2020, the cutoff marks for the short service commission in the Indian Army was 70% for the mechanical engineering branch. For other branches, you can have a look at the Army's website. There are other government organizations like ISRO, DRDO, IGCAR, which I have not listed here, which again give you a lot of opportunity to serve the nation as well as be at the cutting edge of the technology which you're learning in your 4 years of undergraduate curriculum. There are also government companies like NTPC, GAIL, BHEL, HAL, Hindustan Aeronautics Limited. So all these companies, government sector companies, whether it's government organizations or public sector companies, they recruit you either based on an entrance test which they conduct on their own, or through an examination called as GATE, for which you'll have to, as I told you in the case of the Indian Engineering Services exams, IES, you'll have to be very thorough in your engineering concepts which you learn from your first semester. So have a look at these question papers for GATE or the question paper. There are a lot of question papers are available in the website. Just have a look at them when you study each semester, when you start studying the different subjects. Have a look at these question papers. How do they look like? What kind of knowledge are they expecting you? Because so what is expected from the university exam point of view might be slightly different from what is expected when you sit for such competitive examinations. So parallelly, as you study for your university exams, please also look at the old question papers, that is the recent question papers of say GATE or question papers of these companies which when they conduct entrance examinations, because that will give you an idea about how differently you will have to study your subject for these exams as compared to how you have to study for your university examination. The second opportunity available is to go for a higher education after my employment. Now, today, maybe 10 or 15 years back, you'll find people who join an organization after their undergraduate education and they retire from their same organization. Maybe you might have parents like that in your home. You might have grandparents like that in your home. But today, it's very difficult to find such people who join a company and retire or have their entire career in the same organization. People want to switch over. People want to learn new things. So higher education gives you an opportunity to maybe learn something which is, something which is different from what you've done in your undergraduate curriculum. So you can specialize in your area of interest in your higher education. That's in your after your postgraduate study. There are certain industries which also give you an opportunity to do your higher education as part of the job itself. For example, companies like TVS Motors, Tata Motors, etc. They allow you or they send you to carry out higher education in different countries or maybe different institutes within India itself. But once you finish your higher education, like say MS or ME or MBA, you will have to go back to the same company, like say Tata Motors, and serve that company for a few years. But there are companies which give you this opportunity to carry out higher education even as part of your job. So after 3 years or maybe after 5 years of your job, they might give you an opportunity to go and study ME or MBA. A lot of students today have a craze for doing MS after their undergraduate study. Now, remember one thing, place where we find it difficult to maybe comprehend is people who are students who study here in Anna University itself. A lot of students who are showing maybe who are not that interested in their studies here in their undergraduate, when they go to their MS, somehow they get an admission in university in the US or some other country. When they go there, they start signing up like anything. So they're completely different from the way they behave here. Now, on the one hand, we are happy that they're able to come up to their potential, but it will be better if you shine here in your undergraduate curriculum as well as shine there. Because if you perform well in your undergraduate study, you will be able to get admission into a good university in the US. So if you want to get specifically into the top ranked universities in the US or in other countries, you'll have to be very good in your curriculum. So you'll have to be, you should have scored very good marks. You should have very good co-curricular activities as participation in technical seminars, etc., or your participation in technical societies, your participation in internships. So it is all these together which will help you get an admission into an MS in a foreign university, and for which you'll have to write either the GRE and TOEFL, specifically if you're going to study in the US, or you have an IELTS exam, which is an English language test if you have to get into other English speaking countries like say Australia, UK, etc. They recognize both TOEFL as well as IELTS. It will be better if you learn a foreign language. One of the professors was talking about that. Specifically, if you want to get into Germany, it's not compulsory that you need German language, but it's always better if you know German, because even though their curriculum is in English, if you are going there as a teaching assistant, etc., it will be better if you know the language, the local language being spoken there. Specifically, if it's Germany, it's better if you know German. The next opportunity available for higher studies is, what if, say, many of you might have a feeling that I was not able to get into the IITs due for my undergraduate education. For such students, you have an opportunity. For your post-graduation, you can go into these IITs, for which you have to write an exam called as GATE. So this is conducted during the month of, say, the first week of February every year, and it's conducted by the IITs. So again, here you'll have to study the subjects which are there right from your first semester, because the GATE exam tests your technical skills. So your mathematics, what you learn in your first and second semester, they are also important, because you have questions from mathematics also in GATE. So what can help you score better marks over the next person is when you start learning such subjects, which maybe many times what students think is mathematics is not important for an engineer. That's a very wrong notion. Mathematics is very important, because in fact, the foundation of engineering is mathematics. And specifically, if you're sitting for exams like GATE, it's very important that you learn mathematics well, because you have questions from mathematics in your GATE exam also. And then you have government and public sector organizations, as I've told you already. Some of these organizations use the GATE score for shortlisting. So I hope you understand or recognize the importance of this exam called as GATE. So you can give this during your 4th year, that is during your 8th semester. So during the February month of your 8th semester. So the first 7th semester will give, you would have studied almost all the important subjects which are there as part of the GATE course. So or the GATE exam. So you will be able to write your GATE exam during your 8th semester. The next opportunity available is to do an MBA by writing an exam called as CAT, which is conducted by the IIMs. Or if you want to do an MBA in an outside country, say like in the US, you'll have to write the GMAT exam. Some people go to MBA directly after college, and some people would like to gain some kind of working experience by working for 1 to 3 years and then get to the MBA program. That's up to you, and that's up to your interest and how you would like to look at your career after you finish your MBA. So that depends on the individual. So you can make your own selection. The third opportunity available is to become an entrepreneur, where you start your own business. India is a young country with a lot of young people. So you have a variety of opportunities available in front of you. So there's no dearth of opportunities. And the chances of funding, or the opportunities for funding, is also tremendous today. So unlike previous years, or maybe more than a decade back, where it was very difficult to get funding, today, if you have a really interesting idea, people are willing to fund you, and you can become maybe very big in a very short amount of time. You have examples like the founders of Flipkart, what I've shown you. They were IIT graduates who left their job in Amazon and started their own company. So that was mainly started for selling books online, and today you know how big a company Flipkart is. You also have other examples. I've given you an example, a picture of famous Ritesh Agarwal, who started this firm called as Oyo Firms. Many of you know that it's a firm which allows you to book for budget hotels in any place you want. So this person whom I'm talking about right now, Ritesh Agarwal, is a college dropout. So if you're getting a thinking like, say, even without going into a college, I can be successful. Yes, there are people who have been successful without getting into a college. I've given you most famous names behind them: Bill Gates, Mark Zuckerberg. We have our own Kamaraj, who was a chief minister here. But remember, not every college dropout or not every school dropout can be a Bill Gates or a Mark Zuckerberg or a Kamaraj. But if you're a successful engineering graduate, I can give you maybe hundreds, thousands, or millions of examples of successful graduates who are also successful entrepreneurs. So every leading Fortune 100 company, if you take as an example, is led by people who have done very well in their undergraduate education. So remember, undergraduate education is your foundation. So the next opportunity available is follow your passion. Some of you might have got into engineering because your parents might have forced you, or in other fields. I've given you examples of sports person, famous people like Anil Kumble, Ashwin. Then you have people in the film industry who are engineers, but went on to become successful in the film industry. In the Tamil industry, you have Madhavan, you have who's an actor, you have directors who are young directors who are very successful today. But remember, it takes time, as I told you, to be successful. So these were people who who finished their engineering curriculum or course more than 10 or 12 years back, and for their first film to be successful, it took another 10 or 12 years. So you will have to slug it out because it's a very competitive world. So if your passion is there in something else, some other field of art, you can do that, but remember, it takes time to be successful. There are other ways of also being successful. I've given you a picture of our own Chennai's Lydian Nadaswaram, a young pianist. He's only 13 or 14 years of age. Last year, he won an important contest in the US where he won a $1 million contest, beating a lot of participants from other countries. He's somebody who does not even go to school. So he does only one thing. He learns the piano and hours every day. So that's his passion. So if your passion is in something else, remember, it takes several hours of practice to become successful. The small boy, Lydian Nadaswaram, about whom I'm talking about, he said in one of the interview, he practices at least for 10 to 12 or 13 hours a day. So remember, when I say he's not gone to school, he spends more than what an ordinary child spends in school or in college in terms of his passion or in learning what he feels passionate about. And that's the reason he's successful. So if you're willing to slug it out, then success is yours. So I've come to the end of my presentation. You have a lot of opportunities available. Choose wisely. This is a stage where you will have to start thinking on your own, because there's no more you're asking your parents as to what I have to do. Yes, your parents might guide you, your teachers might guide you, but remember, it is you. So your decision is yours. So you will have to start owning your decisions or taking responsibilities for your decisions. So choose wisely, consult others. You have the web, you have a lot of information available, and go ahead. You have a very good career in front of you. Thank you.
Thank you, sir, for showing the importance of studying at different levels and providing information about the broad spectrum of employment opportunities that exist in this field, actually. So, with this, I invite our next speaker, Dr. G. Balakrishnan, who is an engineering manager at Caterpillar India Private Limited, Chennai. He pursued his BE in mechanical engineering from Kongu Engineering College, Erode, and ME in design and production of thermal power equipment from Regional Engineering College, Trichy. His PhD is from Anna University, Chennai on production data management. He joined Caterpillar India Private Limited, Chennai in 2007, and he briefly spent some amount of time in Caterpillar Incorporation, USA. Thus, he has a professional experience of 20 plus years, and his area of interest are engine structures and dynamics, thermostructural mechanics, etc. In addition to serving industry, Dr. Balakrishnan also serves the academia as a member of Board of Studies and Academic Council in several colleges and universities. With this brief introduction, I request Dr. Balakrishnan to deliver his talk. Sir, please.
Thanks, Muthu, for your introduction. I'm aware I'm between your lunch and you. Let me make it a little bit interactive. You can interact by giving your answers in chat, but however, I'm not going to show up the answers. It will be in the background, just to make it some kind of interaction to happen between the presenter and the participants. So I'll just take you through challenges for mechanical engineers in automotive industry at high level. Probably I'll be careful in not touching the areas what is already covered. So this slide depicts how the industry responded.
Sir, your screen is not shared. Please share your screen.
Yeah, you're able to see my screen now?
Yes, sir. Yes.
Okay. Sorry. Yeah. So as new challenges emerge, industries and research institutions, they responded to the challenges, to meet the challenges. I'll just take you through some of the challenges, what is there are presented to the industries around us. Just for example, in the power sector, you know, L&T and BHEL are the ones homegrown organizations who are manufacturing boilers from India. If you go to BHEL, they can provide you boiler at 200 megawatt capacity and 510 megawatt capacity. If you want to go for a boiler which is producing more power than 500 megawatt, we don't have technology in India. You have to go to the foreign countries and then import that technology right now. Of course, BHEL is under pressure to occupy leisure space and produce higher power. So this is the kind of pressure on BHEL kind of industries, power industries, to occupy leisure space and produce more power. In case of thermal power industry, you take other area like aircraft industry. So who are all the commercial aircraft manufacturers in the globe? We have to either depend on Boeing from US or Airbus from France. Of course, there is pressure from the government of India to get it indigenously manufactured. You would have heard when you visit Bangalore, there's a lot of aeronautical organizations, starting from HAL to NAL to GTRE. They are under pressure to bring up commercial aircraft sometime down the line. At least for now, they have come up with lightweight aircraft, LCA, or you call that as Tejas, which is into military operations. Of course, China was successful. Recently, they have announced they got their commercial aircraft ready. So India, sometime they need to bring out their commercial aircraft. There's a pressure on all these government organizations to come out with an indigenous commercial aircraft, so that you don't go and buy from US, Boeing, and then France, Airbus. Similarly, you take the other area like rocket launches. How many launches are taking place from India? We are good at that part. We launch rockets for other countries. You can visit Sriharikota, which is nearby to Chennai. So we had a technology before 2000. You assemble the rocket stage by stage, say 25%, 50%, 75%, and 100%, and then do the launch. It takes 3 to 4 months to clear that place again to start the next launch. That's not the case now. They have mobile launch pedestal. You can have a rocket assembly taking place, maybe 25% in one place, 50% in another place, or all four can be pulled to the central location and then launched from there, so that you are not wasting time in clearing the place. between first launch and next launch. In this way, we have much more capability to launch India needs or meet India's needs as well as needs of other countries. By the way, we are also generating revenue by launching rockets for different countries. Of course, there is also pressure on supplier organizations. I mean, you might know OEM, original equipment manufacturers. For example, Ashok Leyland is an OEM, Caterpillar is an OEM. Any product which has its batch, like Caterpillar or Ashok Leyland, that's OEM. But if you check all the parts in it, that is not completely manufactured or owned by those OEMs. You'll see supply parts like alternator, Viper motors, those were supplied by low-cost TVS. Like Wheels India Limited. Brakes India. India Pistons, they supply pistons for most of the organizations or OEMs in this part of the country. Similarly, tires, MRF, Michelin, something like that. But remember, there is pressure on them to supply at lower cost year over year. If a supplier company supplies part A, takes starter motors, they supply this year for 100 rupees. Next year, I expect them to supply the same product at 90 rupees. However, the material prices will go up, the salary will go up, but the supplier organization is expected to innovate to bring out the product at lower cost. That's the challenge. So organizations are always put under pressure. That leads them to come up with new techniques and technologies. Let me move on. So what is that a customer is looking for in a product? It is very difficult to define. It's a complex equation. A customer expects reliability in the product, safety, maintainability, and so on. And over and above that, environmental effects. It has to operate in the same way wherever you use it. It has to be tested so that it is operating in the same fashion at different climatic conditions. It cannot be like it operates only in South India and you cannot use that in North India. So companies will spend lots and lots of money to make it, to ensure that it reaches customer scan and it works in different environmental conditions. So I've just shown a snapshot of different things, what a customer is looking for in a new product. So this is what the pressure. You have to sync or you have to sync, adapt or evaporate. You have to move or get crushed. So rethink, reinvent or re-engineer anything that slows you down. So this again gives how much time it has taken from concept to commercialization. So transistor, it took 10 years to get commercial product out. TV, 29 years. This is just a glance how much years earlier people were waiting to get the product in their hands. I don't think with current situation, people are willing to wait for those many years to get the product when you have the concept ready. This is a classic example you would have seen in 90s. When you want to buy a car, you had only Maruti and Premier Bhattini. These two are the car options available, and you are supposed to have, if the car is 5 lakhs, you have to earn that 5 lakhs, only then you will get a car. Either it is Ambassador or Bhattini. But now, if you have 2 lakhs, you have a car from Maruti. If you have 20 lakhs, you have a car from Maruti. He needs Maruti supplies or meets different financial status of the customers. So this gives a glance how quickly they were bringing out new models. That means they have done something to make both Ambassador and Premier to close down in India, because they were not able to offer the models, varieties, what the customers are looking for. Almost every 1 or 2 years, you would have seen new models coming out from Maruti. I just listed, the list stops at 2017. I have not added after that. This gives you a scheme how the new product development cycle is compressed. So this shows what is happening at different stages of product development: concept, design, detailed validation, and then product design. So cost of changes at last part means if you make a change at product design, means production design phase, you have to invest a lot. But it is easy to make the change at construction stage. I'll just go through the next slide, which explains you the cost impact. The blue one is one scenario where you are making a lot of changes at the early stages of product development, and then lesser changes at the later part of the product development. The red one, there are changes, but lesser number of changes. It's happening throughout the product development cycle. So you just can answer back whether you prefer red one, red scenario, or blue scenario. Let us see what is the cost impact of red and blue scenarios. So you could see, although blue had a lot of changes at the initial stage of product development, the overall cost per change is minimum. It's at 100K. Whereas red curve, which was having lesser number of changes, but the cost for those changes are very high at the later part of product development, which is not advisable. This holds good even for an engineering graduate when he starts from first semester to last semester. It is easy to correct the mistakes, the cost you pay for your corrections in the initial stages of your semester is lesser and easier, less painful than making your corrections at the later stage or when you are in the final year doing the project. Because you have to meet your that year need plus whatever you are lagging. I'll just explain this with more details when you go into specific areas. So this gives a glance why the organizations are going for new product development. They can continue with the same product without any changes because Maruti gets, there's always pull for Maruti. There's waiting time if you book the vehicle, at least for a couple of models. There were other organizations where they have manufactured product, manufactured part waiting in their stocking yard. So there is something called from government regulations, emissions, which makes the product to change or forces the organization to make changes, and then something called safety. Emission is with reference to what is coming out from your tailpipe or exhaust. So this is there in Ministry of Transport, road transport. You can go and take a look. Which year, what will be allowed to get operated or certified to get operated on Indian roads. If you are not meeting these norms, you cannot sell your products in India. That way, MNCs are better placed. So if they move from high regulated companies to low regulated companies, it is easy for them. So you could see major cities, the vehicles are meeting BS4 norms. If you are in nationwide, you are supposed to meet BS6 norms. Of course, right now we are into BS6 because in between we skipped BS5. Similarly, safety, there are star numbers associated with frontal impact, and then offset crash, and then side impact. The vehicle, the driver who's sitting inside, he should be safe for those kind of impacts which is happening when the vehicle meets accidents. So this drives the vehicle manufacturers to go for changes, even for successful models. That holds good why Maruti has come up with new Swift. Although its previous version of Swift was successful, they changed the new version because there is when it is the old version was not meeting the frontal impact. In the new version, the front bonnet and the space between the engine and the driver, there's a change so that it meets the front impact safety norms. Again, on emission side, so 1991, where we are standing, and as the years move on, currently when a vehicle, when they say this vehicle meets BS6 norms, the relative percentage reduction, say you can see for cars, gasoline cars, it is 92% reduction. It's a huge ask from these automobile industries to reduce their pollution levels. This is one aspect. It could be particulate matter, it could be NOx, it could be SOx. That's the challenge. And those challenges, again, it gets converted into employability for those engineers. You have to come with new technology to make your engines meet these emission norms. Okay, just to give you a visualization impact, you can take your handkerchief, put your handkerchief on the tailpipe, and then you'll be able to wipe your face if your vehicle is meeting BS6 norms. That means your exhaust is as clean as your inlet or atmospheric air. But customer is paying the cost for that. He will not be willing to pay the cost only for reducing the emissions. You have to give much more than that to the customer, wherein he will expect fuel efficiency or better comfort while riding the car or using the product. So this is again a pictorial view of what is the worldwide emission regulations for off-highway trucks. These off-highway vehicles, these vehicles are not supposed to be used on the road. So just take a view at India, the color. So tier 1 to tier 4 for US norms, stage 1 to stage 4 is for UK norms. In India, we follow Bharat stage, which again those numbers were driven from US and UK norms. We are trying to match with global emission and safety norms. You just take a look at what was the request or expected to sell a vehicle in 2011. Just take the color of India, it's tier 3 or stage 3A. In 2016, if you are selling a vehicle, it needs to meet tier 4 interim or stage 3B. So all these automotive OEMs are working on their engines to make those vehicles meet these emission norms or safety norms. That generates employability for the engineers. So I've just given a snapshot of a passenger car. What are all the different things which government emphasizes to make the organization to address? You can go into again the Ministry of Transport and Roads. He will specify different norms for commercial vehicles, passenger cars, buses, and trucks. Again, so this drives the employability of the engineers who are coming out of the colleges. Again, electric vehicles, there's no option. All the automobile industries, including heavy engineering, they're moving towards electric vehicles. If you ask specifically what Caterpillar has done, we have semi-electric vehicles. That means there will be an engine and there is a generator or alternator which generates power, and that powers the electric motor, which were main drives for the movement or mobility of those heavy vehicles. So if you get a better battery technology, then we'll just replace the engine with battery. There's no genset, directly connect that to your electric motors with controls. It's ready, electric ready. Probably you can Google it. There are dosers which are already electric vehicles. We also use gensets or engine and then hydraulic. The drives will be hydraulic in some cases. Take the case of hydraulic excavators. You have engine that drives hydraulic pumps, and that hydraulic energy is used as the primary source of movement of those vehicles. Hydraulic pumps will be driving the vehicle in case of hydraulic excavators. You can just Google it to understand much more details. Similarly, autonomous vehicles. So autonomous vehicles might be a luxury for auto industry, what they are trying now. For industries of our nature, where safety, we spend tons and tons of money in ensuring the driver safety. So even now, when a driver is sitting inside the cab, we ensure the driver is meeting fallover protection, rollover protection, and then operator protection system. That need to be physically validated and then virtually validated before that is put into operation, and it need to be certified. We spend a lot of money in meeting those safety certifications. So to do away with that, few years back, we did have autonomous vehicles which is operating remotely inside mines. Means think of going inside mines where there is a lot of chances of landslides, which calls for autonomous vehicles. We do have solution, which is already available, but not in mass production. There was no takers at the time when we offered. Now it is becoming attractive, and there are takers for autonomous vehicles. So passenger car segments, it's just evolving now, but in mining industry, it's already there. And if you take Internet of Things, yes, there are already connected vehicles when you're operating inside mines. Try to minimize as much as possible the human presence. Let the vehicles interact, speak, and then let them operate automatically. Where the solution is Internet of Things. The vehicles will speak to each other, and then they get operated from a remote location. So with that, the chances for engineers, you can be a design engineer. Only thing, you need to be thorough in your design concepts, starting from strength of materials to your design of transmission systems and design subjects, and then maybe a couple of modeling tools. See, these tools are like spanners. Tools will not help you. You need to be very strong in your fundamentals, starting from strength of materials to your design subjects. Detailing, you have to be strong in your modeling, say your drawing, engineering drawing, and machine drawing. Those two are the core stuffs which is required for detailing. Of course, you need a tool knowledge to be successful in that domain inside an organization. Then virtual validation, computer-aided engineering. So you need, again, strength of materials, and then a couple of, if you are in a vibration area, you need to know that. And then failure theories, of course, again, design. After that, tool knowledge. It could be FEA or any software tools. If it is non-linear, you go with Creo Simulate or ANSYS. If it is non-linear, linear, go with Creo Simulate and ANSYS. If you go into non-linear, go with Abacus. You need to choose this tool accordingly in which zone you are operating. Of course, once you are thorough with your virtual validation, then CFD area also comes into, which falls under CAE. Of course, when you are done with that, then you can go for physical validation. Like you need to know about strain gauges, Rosats, accelerometers, then EDAX, which has the data orchestration part, microdot tables, all those systems. It is niche and specialized. You need to be very strong in vibration area again when you're going into physical validation. Not many are available. Very less job opportunities, but not many engineers are also available for those things. It's challenging. You have to be very strong on your fundamentals. So again, I want to say, without fundamentals, only tool will not help you. You cannot have long career. Like, of course, vibration and noise. So when just take starting from your mixie to grinder to your washing machine to dishwasher. There's a specified limits on dB levels when you are installing those machines in domestic areas, even gensets. So when you just go and take a look at gensets, there will be an enclosure cover on the top of the genset when it is placed in domestic areas and hospitals. It has to meet the noise levels, dB levels. It cannot be more than that. Once you go for more than 1000 kVA in India, it cannot be installed near domestic area or near hospitals. It should be in industrial areas. If it is in domestic area, there are noise levels. You have to meet those numbers. So you have to do a lot of R&D to reduce the noise levels. Starting from washing machines, dishwashers, yes, there are stringent norms. They spend a lot of time in reducing those noise levels. Of course, emissions, if you want to touch emission part, then you need to play with fuel systems, your combustion chamber, and then exhaust system as a whole. Safety, yeah, structures part, your say impact and things like that. Of course, you need to meet ISO and fast requirements. Then electric vehicles, yes, drives, battery technology, all those things are emerging. Maybe I can't say it is emerging, it's already there. Only we are not accepting that. We are just in a dilemma. We are going to see more and more battery vehicles. Of course, autonomous vehicles, it's already there. It's not like in some areas it's already there. Maybe at that point in time, no buyers. Now there's a lot of interest, there will be buyers. Okay, with that, so I was asked to give a success template. There's no success template. At least if you choose your area and then develop your skills starting from your early semester to final semester. Don't juggle. If you feel like you want to be in vibration area, ensure you're thorough in your vibration related subjects. Try to go for a few internships, and then your resume should speak peace and vibration well. So at times we have received in resumes and then forwarded to concerned teams. When the resume speaks, he's a vibration man, he's a CFD man, he's a success man. If you have a generic resume, that's not going to help in referring your resume to different departments. Okay, with that, this is my last slide. If you ask what is success, our secret of success, you have to dream or plan, maximize that. You have to put your action. If you only plan and dream, if you don't put your action, that's not going to help. There will be fear. For all, there will be fear factor. Try to minimize that. With this, I think I'm just a bit on my time. Thanks for the opportunity for Science City and all the participants.
Thank you, sir. Thank you for your insightful speech. So we are in the last part of today's program, where now the session is open for discussion. What I have done is, like, I have taken the questions which the participants have posted on the chat box. I request all the speakers to unmute so that I'll show the questions one by one, which you can address. We can quickly do this in next 10 to 15 minutes, and we can wind up with this session. Shanmuga Sundaram sir, I think this question came during your talk.
I would not specify a single programming language, because depending on the industry, it is kept on changing. So it would be better that if the basic programming languages like C++, your Python is very well known to them. And of course, as mechanical engineers, if they could learn MATLAB programming, which is once again dependent on what kind of application, whether it is for a CFD application, whether it is for a design application, naturally the mathematical skill is going to help them fit into the industry.
So, to add to Shanmuga Sundaram's answer, I would say if mechanical engineers are good at programming, if a mechanical engineer with inclination to coding, it will help all these commercial tool or solution providers. Like, you could be a developer at ANSYS, you could be a developer at Abacus, because you have to be strong in mechanical and then strong in coding. It is very difficult combination, a rare combination. I have discussed with Abacus team, technical team, they find it very difficult to get. Even CAT, we are looking for this combination. We don't need more. So I don't want all hundreds and thousands of students to go for this stream. If you have natural liking, take that. There are few opportunities for very strong candidates in both the fields. You're mechanical plus coding.
Yes. Creativity and innovation. Of course, apart from the basic knowledge on the various design aspects, starting from using your mechanics, your engineering skills of designing the different components to the system design, you should also augment your skills of using the commercially available packages. As the previous question, Dr. Balakrishnan also said, you should also learn writing the programming codes, because today, as I was mentioning in my lecture too, every industry wants to have their own code for making the analysis to make them foolproof and to protect their intellectual pattern. So these are the skills that are needed, specifically if you wanted to be only in the R&D of the mechanical engineering discipline. As of today, 3D printing is seen only as a tool during the concept generation. And near future, probably it is also going to to a certain extent going to replace as a manufacturing sector, but how far, how effective, it all determines, it is all determined by the cost and how many people are ready to adopt it, because so much of money has already been invested in the conventional and computer aided manufacturing tools. Suppose if 3D printing has to become a viable platform, naturally, it has to have a lot of manpower working on it to reduce the cost, to make the people accept the manufactured product. So to do that, as of today, yes, 3D printing is going to have a huge impact, and all the major universities and educational institutions have started to introduce that as a elective course as well as a practical course. So maybe down the lane 4 or 5 years, definitely this is going to have a major impact in India. I could have probably the last slide of Dr. Balakrishnan was also giving an impetus on this. Artificial intelligence and machine learning not only is going to be useful for the autonomous vehicles, but also the industry 4.0, where artificial intelligence and machine learning are the substitute for understanding the real-time data and making the tools to give predictive maintenance, as you could see in the in the assembly line or wherever it is, and to augment the faster product development, because this artificial intelligence tool and your machine learning tool are going to reduce the total lead time. So if you are going to reduce the lead time, naturally the product is going to be reaching earlier to the market. So these are the immediate things that we can understand as a Bachelor of Engineering student, as a +2 student. But as you enter into learning these two courses, you would definitely be able to acknowledge the fact that artificial intelligence and machine learning is no way different or difficult to understand, but it is going to be part of the product development activity, wherein everything is going to become computerized and electronics based controlled product. Well, your question is more relevant to entering into the industry. So you could have heard to the people working in the industry. So apart from the basics of learning the industry 4.0, as well as you could see, still more advancement in the next decade, you should start learning how to apply your creativity and innovation. So you should start understanding how the courses which were seen only as the computer courses or electronic courses could be integrated onto the existing products. So if you wanted to enhance the existing product, so those kind of courses, I cannot specifically say this course is going to be advantageous at this point of time. So you have to keep upgrading your knowledge as and when it comes. As of now, whatever the open electives which we are mentioning about, apart from the artificial intelligence, your machine learning, deep data, and we are talking about smart manufacturing systems. So those kind of courses are the ones which are quite relevant, and skilled in any one of these is going to put you as a potential candidate to work in the future industry. So I forget to inspire the girl students. Definitely, there is no difference between a male or a female specific to engineering. And to be honest, today, most of the mechanical engineering activity, as you could see, is almost substituted with an automated system. So you could find lot of job opportunities, and once this 33% reservation of women has come into the job of both the government as well as the public sector as well as in the private sector, every people have started to accept that it is not a tough task as it was initially assumed, that they have to work on machines. They used to carry huge weights to work on the industry. But today, everything is computerized, everything is automated. They can also work as a white collar job similar to any other disciplines of engineering. And to be honest, every girl student who are studying in the Department of Mechanical Engineering, as I've seen for the past 20 years, are having more than minimum 20 to 30 possibilities as compared to the male student, because the Mahindra and Mahindra, they have started to introduce a new scheme of hiring minimum number of girl students, and there are only 3. All the 3 students, even they had a minimum mark than the boy students, they were able to get their jobs. So it is the time that the girl students should understand that mechanical engineering is no way only a male-oriented engineering course. It is as good as any other engineering course. You can also opt for that. Well, my friend Dr. Samuel was also giving an impetus to entrepreneurship. To be honest, it is less than 1% of the total graduates of the higher education, irrespective of arts, science, engineering, medicine, they wanted to become entrepreneur. The simple reason is the risk associated with it. And the second important thing is exceptions are not examples. Even Dr. Samuel tried to inspire you by quoting the examples of even failures. But you could see in the recent past, the great Ratan Tata has invested in one of the pharmaceutical industry, which is just owned by an 18-year-old graduate, and 18-year-old school student in the generic Aadhaar. So if generic Aadhaar, a 18-year-old student could inspire the great doyen of the manufacturing sector, or the great entrepreneur that you could see, Mr. Ratan Tata, definitely you should think of becoming an entrepreneur, because every day is a challenge. As I was mentioning, the placement recruitment procedure has completely changed. Only your skill is going to get you jobs, and if you wanted satisfaction additionally to it, added with passion to your life, naturally entrepreneurship is the best source. And definitely I could see most of the people who became entrepreneur from our experience as friends or students, they are doing extremely well. And it is not that failures are not going to be there. As Dr. Kalam said, you start with a failure, even the great mathematics starts with 0. So you start with no knowledge, but as your life takes towards um, its own course, and one of the industrial experts said you could go logarithmically, and fortunately there will be choices. If you are too passionate, you will become extremely successful in your life. And entrepreneurship is the only thing that would give you immense joy. If you are going to see whatever the hard work you put in, you get it back. So it is better that you take calculated risk at every point of time. It is not that I'm inspiring you to become an entrepreneur. There are too much of things that are associated. In countries like India, challenges are more than the easiness of becoming an entrepreneur. So learn from things, be a worker for a few years and learn the trade of the thing and become an entrepreneur. That is the advice I would give to all the people who are interested to become an entrepreneur. Well, every gate score in more than 95 plus is what you would get it, because as I could see, it is not that every public sector or other people are not interested in GATE. Everybody today, it is one of the easiest methodology of getting an easy feedback of how well or knowledgeable you are in knowing the basics. So these public sector units do specify, as I was going through the lecture of Dr. Samuel, he very clearly said it is minimum 70%, 70 percentile. So if you are going to have 70 percentile, you are going to be called for. But once again, people with as high as 90 and above, even for the reservation, they are the ones who are going to be considered higher if you wanted to get into bigger PSUs. Most of the courses that are available in the NPTEL as well as your Swayam platforms are those that you cannot see it offered in your college or probably in even Anna University. So I would rather suggest, if you are going to choose courses based on your interest to learn or join the industry. If you are interested in your automotive industry, I would rather suggest you choose any one of the analysis type of tools, starting from NVH to your CFD to your things that are related to your automotive industry is more good. But if you are interested to pursue your post graduation, then and work also once again at a higher level in your automotive industry, yes, I would suggest data analytics. You can go for deep data, you can go for artificial intelligence, you can go for machine learning. Because as of now, not good expertise is available with the Faculty of Mechanical Engineering, but try to relate. And of course, every engineer should undergo a course called product design and development, because everything that you do today is with respect to development of product. So finally, it is going to be the product. So the challenges that you are going to come up during the course of manufacturing or converting your idea into a final product or choosing the right material, you would be able to understand how you have to go about when you are going to study the subject product design and development.
Actually, Professor Ganesh has already answered the question on the chat, but I just kept it because it might be useful to the other viewers also who didn't read the chat.
Yes, yes.
But I think he is not on his bench. So the answer is already there in the chat. At least that I can assure to the audience. So with this, we are almost in the end of the session. I request Dr. N. Radhakrishnan, Assistant Professor, Center for Advanced Studies in Botany, University of Madras, Chennai, to deliver the vote of thanks.
So good afternoon, everybody. I am pleased to propose vote of thanks on this webinar on career in mechanical engineering. So first of all, I would like to thank Professor K. Sundaram, Professor S. Balasivanandha Prabhu, and also Professor Samuel Raj for giving us an overview and a consolidated view on scope and opportunities of mechanical engineering. I would like to also thank Professor D. Ganesh for giving us an overview on automobile engineering and its challenges and opportunities. I would like to also thank experts from Caterpillar India Private Limited, Dr. G. Balakrishnan and Mr. Shankar Subbaratanam, for enlightening us with the industry perspective of mechanical engineering and also the learning opportunities to the students. I would like to thank the Vice Chairman of Science City, Mr. Sagayam IAS, for his commitment and motivation. I would like to make a special thanks to Mrs. HEMAA, Senior Scientific Officer, and also Administrative Office staff of Science City, Chennai, for their commitment and support. My special thanks goes to Dr. Muthamilarasan, a member of Indian National Young Academy of Sciences, and also faculty of Plant Science Department, University of Hyderabad, Telangana, for his coordination. Finally, I would like to thank all the participants for their interest and participation in this webinar. I hope this webinar is useful for all the budding mechanical engineers and also engineering aspirants. Thank you very much for the opportunity.
Thank you, sir. With this, today's session comes to an end. Thank you.